Some of you may know, some of you may not know, that NSWC Crane was named as only one of 6 TechBridge sites across the country. And my organization, IN3, is partnering with Crane to host a number of events such as this, but this is our very first. I think I'd like to call it our maiden voyage, since it's Navy. We're excited to have the opportunity and are delighted to be part of something that is truly a first of its kind initiative. You'll soon hear from Ann Fields about the overarching goals of TechBridge, but in short, it's focused on finding the best and newest technologies like yours to get them more quickly into the hands of the warfighter. COVID-19 has presented us all with a series of more than significant challenges, and I hope you know how much we appreciate taking time out of what I know are incredibly hectic schedules to join us today. It certainly would have been preferable to meet person to person, face to face. Those are important collisions, and we'll do those in the future. But I'm certainly convinced that regardless of the fact that this is virtual, we'll achieve the same result. A couple of things before we get started, a couple little ground rules. So I'll be the MC. I'll try my best to keep everybody on track. Presenters, if you'd be kind enough to let us know when to advance your slides, we'll do that from our end so that we know that everyone will see the same thing at the same time. For those of you who might have a couple minutes left in the 15-minute slot, we'll try to field a couple of questions, but if not, if there is time, there's a chat function at the bottom of your screen. So would encourage you to use that if at all possible. We will capture all of those and we'll be sure to answer them all and just as swiftly as we possibly can. Again, since we have a full agenda and without further ado, I'd like to introduce Ann Fields, who has been just a terrific partner to IN3 through this very new initiative. She just joined in her role less than 6 weeks ago, but she's been terrific and serves as Regional Director of Midwest Naval X TechBridge. So Ann, you have the floor. Please take it away.
Thanks. So thanks so much, Julie. Really appreciate it. I want to thank you all for being here today. I know, to echo what Julie said, I know we've all got hectic lives going on right now, got a lot going on at home with the COVID-19 stay-at-home order. So I just appreciate your guys' time and attention for this first event that we're doing. As Julie mentioned, there's a chat feature on the bottom of the presentation. So I welcome you guys to use that at any time. Jenna was kind enough to kind of kick us off. But if you have any questions during the webinar, feel free to put your message in there and we'll get back to you. If we don't hit the message during the presentation, you guys should have had your name and email addresses in there, so we could have the individual that you're interested in talking with get back with you after the meeting. So again, just appreciate your guys' participation, and we certainly would appreciate any feedback you have after this event to make our future events that much better. So I'm sure you guys have heard about the Naval X Midwest TechBridge and the other TechBridge initiatives. So Naval X actually stands for Naval Expeditions Agility Office. And so in February of 2019, Assistant Secretary of the Navy for Research, Development, and Acquisition, Mr. James Hondo Gertz, started this initiative. And so the Naval X team, there's kind of a couple different pieces to that team. The Naval X team has a physical space in Alexandria, Virginia. There's a co-working space there and a tech shop with the goal of examining and understanding problems, capturing innovative agility methods, growing ideas and crafting solutions. And what's really interesting is since I've been on the team for the couple months that I've been here, I've seen this in action quite a few times, but none more than with the COVID-19 pandemic recently. That Naval X team has done a phenomenal job kind of coming together to bring all of the warfare centers and associated ecosystems together to bring solutions to the problem that faces all of us. The Naval X team is also regionally staffed from across the Department of the Navy. And the Naval X goals are to have a faster Department of the Navy, a more agile Department of the Navy, and in some instances, perhaps more lean and definitely more connected in order to outthink and outpace our adversaries. And that would give us a decisive advantage over the warfighter. So the idea is to make this network connected and have it be an enduring connection that benefits the warfighter long term. NavalX is looked at as an agility tool to try to bridge innovation and capability in different ecosystems. The idea is to connect pockets of various organizations with innovative ideas rather than generating ideas of its own. So we're really here to be that super connector and that matchmaker for problem-seeking solutions and solution-seeking problems. And our goal is to further collaborate and develop more connections across the Navy, private sector organizations, and other groups around naval bases. So if we can go to the next slide, please. So that gets into the tech bridge initiatives. So with that kind of overarching NavalX goal, the idea with the tech bridges was to bring that same sort of agility and innovation ecosystem connection across the United States. And so if you look at the slide here, you can kind of see of the different sorts of groups that are out there. Innovation groups. There's different cells that we need to coordinate between. Of course, then there's central coordination and then a micro ecosystem. So the micro ecosystem is what exists in a lot of the communities around us. And then our goal is to kind of bridge that gap together. The idea of the tech bridges is to connect, reinforce, and sustain. And you'll hear me say that a few times, but reinforce and sustain the existing ecosystem. So the tech bridges are designed to capture the culture of innovation in key locations across our nation. This endeavor is a combined effort between ONR, the Office of Naval Research, and then Navy System Commands to again connect, reinforce, and sustain the acceleration of ecosystems to enable key partnerships. So if we can go to the next slide, please. Thank you. So that kind of shows all of those smaller organizations coming together and being bridged together. So I look at the tech bridges job as to kind of building and maintaining those connections. So this is kind of an overarching idea of what a tech bridge is, and there are currently there are 6 tech bridges. So there were 5 initial ones that were rolled out in September of 2019. Currently there Newport. Oh, if you guys could go on mute, that'd be awesome.
Yeah, please, that'd be great. Thanks.
The first one is in Newport, Rhode Island, Keyport, Washington, San Diego, California, Orlando, Florida, and Crane. And then there was one more rolled out in November 2019 at the Palmetto Tech Bridge in South Carolina. So each one of those tech bridges is in a different space of the connect, reinforce, and sustain. We've got somebody not on mute. If we could just go on mute real quick.
Attendees can now hear you speak. This meeting is being recorded.
Okay. So yeah, so each of those tech bridges is kind of in a different space. And one thing that the Crane or the Midwest Tech Bridge is one of the 2 that was actually in the sustain space. So the Midwest Tech Bridge and the one in Orlando, Florida are the 2 that are really mature, which just goes to speak for everybody on this phone call. Our ecosystem is phenomenal. So I look at my job as just really helping that in any way that I can. So if we could go to the next slide, this next slide kind of looks at the 30,000 foot view of the Midwest Tech Bridge ecosystem. And like I said, I really look at my position to improve and enhance our ecosystem in any way that I can. And I think the way that I plan to do that going forward is to get processes and procedures in place to ensure that that network sustains long after, 20 and 30 years when all of us have retired. We want this, the work that the team has put in to sustain long time from now so that we can support the warfighter in years to come. So one thing that I would like to focus on in the near future is a widely communicated calendar of events that we can share with all of our partners in the ecosystem so you guys can see where the Midwest Tech Bridge is and what we're focused on. We really want to focus on internal and external engagement. And we eventually want to have space, physical space for innovation to happen between all of our partners within the ecosystem. So that's kind of the quick overview. I know I don't have too much time to chat, so I just really appreciate your guys' participation. Thank you so much for being here. Please participate if you can on the chat function. And without further ado, I will turn it back over to Julie.
Hey, thanks, Ann. Terrific job. And you'll see Ann a lot. You'll also see us together a lot, which is something I look forward to. We've already started to kind of travel the highways and byways of Indiana, so more of that to come. But in the meantime, I wanted to introduce you to Jenna Dix. Jenna has a very significant and important role at Crane. She's in the Office of Research and Technology and leads the tech transfer effort there. In fact, she's director. So Jenna, please.
Thank you, Julie. Hi, everybody. We're really excited that you're here today. So I am Jenna Dix, and I am the director of the Technology Transfer Program at NSWC Crane. What I'm hoping to do quickly this morning is to give you a little bit of an idea of what the Technology Transfer Program is and how it might be able to assist you. So as you are giving your technical presentations today and in the future, as you hear about the problems and solutions that we are seeking at Crane, you'll have some ideas in your mind as to ways that we can partner that are kind of outside of that standard acquisition framework. So Derek, if you could go to the first slide, or there you go, thank you. So the Technology Transfer Program is really about enabling access to the resources that we have at the federal laboratories. So these assets include things like knowledge, intellectual property, technical data, our technical experts, our specialized equipment, our state-of-the-art facilities. So the whole idea here is that everything that we do within Crane and within the federal laboratory system is paid for with taxpayer dollars. So where appropriate, we are charged with enabling that the public and small businesses, industry, and academia have access to these resources that are inside the laboratory. So we're really trying to make sure that we are leveraging the investment into the R&D in the lab system to promote dual use technologies and to encourage economic growth. Next slide, please, Derek. So this slide is just a little bit more of an understanding to kind of give you an overview of what those assets or resources within the lab look like that you might be able to access through the Technology Transfer Program. So on the right side, you just see some basic technical areas. So these are a lot of the technical areas that we participate in and play in and have expertise in. So you see things like optics and lasers and communication systems and software, electronics. All of these different things and more are areas that we have expertise in. We have some type of resource that could be of value to you, and through the Tech Transfer Program, we'd like to help you get access where that might be needed. So first we have our intellectual property portfolio. So we have about 300 pieces of issued patent intellectual property, so issued patents, a number of other patent applications that are pending issuance. So we have a pretty robust IP portfolio that can be licensed, which I'll talk a little bit more about the licensing process in a moment. But the intellectual property can be accessed in a variety of different ways. And so one of the great things about the IP that we have at Crane is because we are a transition laboratory and it is really our responsibility to transition technology to the warfighter, a lot of our intellectual property is prototyped and fielded. So while we do have some early stage technology in our portfolio, a lot of what we have is much further along in the development life cycle and even in a lot of cases fielded and in use by the warfighter. We also have a really young portfolio. And when it comes to intellectual property, this is important because the life of the patent is still pretty long. So most of our intellectual property has been disclosed and protected within the last 10 years. So this is a good thing, and it makes puts a lot of value into that portfolio. We also have over 2,000 scientists and engineers who are subject matter experts in these fields that you see on the right side of the screen, and many others. So as you're working through your tough technical problems that you're working on within your business, and you need, you could use the assistance or some help from somebody else in that field, we might be able to help you in that manner. We also have state-of-the-art labs, equipment, things that just aren't generally found in the commercial marketplace that we can facilitate agreements to enable access to those types of things. And lastly, testing services. So this is paired pretty nicely with the one prior as far as equipment and facilities, but we have unique capabilities to do a variety of different types of testing that we can, that you can access through the technology transfer program. Next slide, Derek. All right, so this is a slide that just portrays 3 of the primary ways that we partner with industry and academia. And there are certainly other partnering opportunities that our program offers, but these 3 seem to be the most applicable, I think, to the conversations today and for you to kind of keep in mind moving forward. So the first is the CRADA, the Cooperative Research and Development Agreement. So the great thing about a CRADA is that this is a really flexible partnering mechanism, and it allows us to do a variety of things working collaboratively with industry, academia, small businesses, entrepreneurs. So a lot of times we will use CRADAs to just enable access to these shareable assets that I've been talking about, like our equipment, our facilities, our people, our intellectual property. The CRADA enables us to do that. So all these agreements are outside of the Federal Acquisition Regulation, or the FAR, so they're not subject to the same types of requirements that a FAR contract or a FAR agreement would be subject to. So we're able to pick our partners and to you know, basically define how we will work together, and whatever might make the most sense for whatever your particular needs are. So we don't send funding out on these agreements, but we can provide a lot of things that are of value to you, as opposed to funds, as mentioned before, access to our equipment, our facilities, our people. So these are great mechanisms. So as you're participating today and in future conversations, if you have a technology, for example, that seems like it would be a good fit with one of our capability gaps, but maybe it needs some further development, or it needs to be ruggedized for a warfighting scenario or environment, we can enter into a CRADA and we can jointly do that development together. So these can be really powerful tools. So keep that in mind as you're engaging with the Crane subject matter experts. The next agreement type here is testing services, and this is really a broad umbrella. There are several different ways that we partner with offering testing services, but this is really a fee-for-service arrangement. So if we have a piece of equipment or a testing capability that you think it would be of value for you to get access to, or to have us perform testing for you, all you would need to do is connect with us, and we would work together to put an agreement in place. We would perform the testing and provide you with test results. So this is the type of thing where there isn't a lot of collaboration. We're basically just performing for you, executing some type of work for you, and you're paying us for it. So we do a lot of these types of agreements just because of the nature of the specialization of the equipment and the capabilities that we have at Crane. And then the last agreement that I wanted to touch on is the patent license agreement. So this is when I talked about the intellectual property portfolio previously. This is really what enables industry and small business to really make and use the Crane technologies that have been patented. So the great thing about the patent licenses with the federal government is that it's a really different situation than if you were looking to license technology from academia, for example. So because patent licenses are really part of this technology transfer program, where the whole point is to enable access to the technologies that have been developed in the laboratories and to promote technology commercialization commercialization and dual use applications, we have a very nice and inviting agreement for the patent licenses. So the fee structure and royalties and things like that, why they're still existent in our patent licenses, they're very different from what you would find in academia, because we are not in the business to make money. We are in the business of getting the technology into the hands of the commercial marketplace, but just at the same time being able to incentivize the brilliant scientists and engineers who are coming up with these great technologies. So most of the revenues that we bring in under patent licenses just go directly back to our inventors. So this was just intended to be a really brief kind of get you thinking about technology transfer and what opportunities you might be able to pursue. And on the very last slide, Derek, if you would flip forward, is contact information for my office. You're definitely welcome to reach out to any of us or to reach us through the technical person at Crane that you might already work with. If you post a question in the Q&A or in the chat feature, we will definitely get back to you, and I look forward to hearing more from each of you.
Jenna, thanks so much. Terrific job. I learned a lot listening to you. I'm sure everybody else did too. Next, we have Chris Jeffers. Chris has been with PTAC for quite some time, does just an absolute terrific job as State Director of PTAC. So Chris, if you're on, we're anxious to hear from you. Chris? Derek, can you tell if Chris has joined by chance?
She's on and she's unmuted and ready to go.
Oh, okay, good enough. Thank you, Chris. I gave you a fabulous introduction. I'm not sure if you heard it. I'm kidding. We're anxious to hear from you, so please, you have the floor. Chris?
Julie, while we wait for Chris, if you'd like, there's a few questions in the Q&A that I can answer.
Oh, please do.
Okay, so the first question is, how does a company go about exploring the possibility of a CRADA, and what is the normal timeline to establish a CRADA? So the first thing that we would want to do is identify what it is that you're seeking, like technology-wise. Is there a particular area or problem that you're looking to engage with us on? And so then we would try to really get a good understanding of what your objective might be and what you're looking for, and then pair you with a subject matter expert from our community. And so we'd go ahead and make that connection, start having conversations. Are we going to be able to find value and benefit for both parties in a partnership, and basically just kind of explore what it might look like. And once we really establish what that is, the process is pretty simple. So we gather some administrative data and we create a statement of work. And usually once the statement of work is submitted, you're usually only looking at about 30 days to get a CRADA in place. The next question, and Julie, you cut me off if needed, okay?
Yes, I will, but I doubt it, so go ahead.
Okay, the next question is, can Crane bring testing capabilities to a CRADA? Absolutely. So the difference, really, whenever we first start talking about whether what a partnership might look like, instead of coming to the table with the idea that we want to do a CRADA or we want to do a testing services agreement, we try to get the parties together to just understand what the objective is. So what is it that both parties would like to achieve? And so if there is value and benefit for the government, then we can definitely explore using a CRADA as opposed to a standard fee-for-service testing agreement. There may still need to be funds involved. It kind of depends on what the situation is and how well it ties to, you know, some value proposition for Crane. But we can absolutely do testing, and we do that a lot, actually. We partner with companies who are looking to enter the supply chain, for example, and they need to ensure that their products meet the requirements that the supply chain lays out. And so we will work with them together in a collaborative fashion under a CRADA. We'll do testing and we'll provide, you know, results and do some collaboration on what might be, you know, how might you better your product or your technology to make it acceptable for government or military use. So we can definitely bring the testing capabilities into a CRADA, and that's one of the great things about a CRADA. So we can do so many different things under the CRADA. There's one absolute that we cannot do, and that's that we cannot send you money. So because it's outside of the FAR and a few other reasons, we cannot send funding on a CRADA. We are not authorized to do that, but we can do so many other things, and that's what makes that such a powerful partnering tool. Let's see, one other question, and then we can maybe move on. It states the U.S. combatant commands publish a common capabilities needs list each year to inform the community about their technology gaps. Is there a similar document available from Department of Navy? I don't know the answer to that. I would assume so, but I can't be 100% sure. I will speak directly from the Crane perspective, though. A lot of times what we will do as far as technology gaps, while sometimes we may not have it in a publicly releasable format, but if we have a company or a partner that we're really interested in engaging, sometimes we might share our internal R&D projects with them. Like, what are the high level problems that we have at Crane that we are trying to solve with our own internal R&D. And then, as you know, as our partner can look through that list of what it is that we're working on internally, they can start to identify areas where they might be able to assist. You know, the third thing on the list might be their specialty, and instead of us you know, working on our own to complete a project or to find a solution, we can then partner with that company via a CRADA or some other mechanism to get to that solution for the warfighter faster.
Great, thanks, Jenna. And you have impeccable timing. Chris Jeffers just joined us, as mentioned. Chris is the State Director of PTAC, has just a wealth of experience. Chris, sorry for the technical difficulties, but we look forward to hearing from you.
Can you guys hear me?
Yes.
Okay, I don't know what was going on. I was on and listening the whole time. It just wouldn't let me speak, so I got out and re-entered. So thank you. Thank you, Julie, for putting this together. You're a great partner. You do great things. Everybody knows that. As Julie said, I'm with Indiana PTAC. We're a part of the Indiana Economic Development Corporation, or IEDC. We are funded by the DLA, which is soon moving, the program's moving to the Department of Defense. So I just want to go over quickly some services that we offer here in the state of Indiana. One of the great services that we have is we partner with people like Julie and IN3, and there's networking opportunities and opportunities for companies to get to know each other and get to know resources, and maybe some government contracting opportunities come along the way. Next slide. Quickly, this is just a little bit about PTAC and the offices that we have throughout the state of Indiana. We give assistance to small businesses, whether it's networking opportunities like this or counseling. We have a free bid matching service that our clients are able to use, workshops and training. And again, we're funded by the state of Indiana and the federal government, so it's no cost to you. Next slide. So the fiscal year 2018, the numbers from, this is just my call to tell people why you want to get in the space of doing government contracting or working with the federal government. As you can see, the the small business goal that Department of Defense has had in fiscal year 2018. I just want everyone to see how much money they did in that field, and that's a B. I always tell people that's a B, 72 billion. The two areas that are in red, that's where they did not hit their goal, Department of Defense, and they did not get a good grade from SBA, and so they are committed this year before the virus, which they will continue to try to hit. They are going to hit the women-owned small businesses in the hub zone. They'll be probably doing a lot of set-asides to hit that goal. Next slide. So right now, I just wanted to talk about some resources that are available to you. I think it's important. IEDC has a response team and a website that you can go to. SBA and their economic disaster loans, their payment protection plans, those type of things. I want to provide you guys with that information. FEMA and Department of Health. And so basically what's been going on in the last 2 weeks has been FEMA and DLA and all these agencies. FAA issued a solicitation yesterday. People are changing gears, and so the amount of cooperation we've had in the state of Indiana has just been remarkable. Most companies are calling saying, how can I help? We don't usually make those things, but we can. Or you have companies that make those things and can really up their production, but they need a new supply chain or they need new connections. So we've really been working hard. Indiana companies have been great. We have a great network. Of course, then it all comes down to, are you in SAM? Some companies let their SAM expire 15 years ago. And so a lot of issues with trying to get them all up and going. But we will be issuing special notices. There's also a state of Indiana response team. So if you are any, PPE right now is where the demand is. But of course, if there's any way you can help or be a part of that supply chain, please let me know. So that's kind of where we've been right now. But without the resources of this COVID-19, the same thing applies, right? So we want to be that resource and help you find resources for opportunities as well as connections of other companies that could help you along the way. So next slide. That's just where you can get more information about IEDC. That's my agency. Next slide. And that is my contact information. And that's all I had. I kept it. Yes.
Oh, no, thanks so much, Chris. And for everybody on the phone, and I'll say this again at the end, we'll make sure that everyone who has participated will receive everyone's name and title and contact information. So if you don't capture it here, just know there'll be a follow-up communication with you so that you'll make sure to have those contacts readily at hand. Chris,
Fantastic.
anything else
And
you'd
again,
like to share?
the only thing I would like others share is if you have an existing contract, it's amazing how many companies we've talked to, everyone's aware of the situation, but that does not mean you get a pass if you have an existing contract with a deliverable or a contract date. So you've got to reach out to your contracting officer to make sure they're aware. We just got notice from the Pentagon and Department of Defense today with some guidance of how to make sure that your existing contracts, that if you can't meet it, what your rights are. So again, you have my contact information, and I'm sure Julie will send it out, but I'd be more than happy to share that information with you. But again, we don't want you to get a bad CPAR or some rating if you do have an existing contract just because you assumed everyone knew that you wouldn't be able to deliver or whatever it may be. So that's it.
Great. Thank you so much, Chris, for joining, and apologies for some of the technical difficulties.
No,
I guess we should
by my end.
perhaps expect that since this is kind of a different venue than which we had originally hoped. But we have the pleasure of hearing next from Damir Kavar. He is the CEO and co-founder of Semmering. Damir and I have been in contact over the last several weeks, and Damir, we're delighted you could participate, and so please take it away. You have the floor.
Thanks a lot for making this possible and for inviting me. I can introduce a little bit about Semmering, what we are doing. We are a C corporation that started as a startup in Bloomington, Indiana, that was founded by faculty members at Indiana University and graduated students. and is basically focusing on content analysis of text, image, and spoken language, and extracting information and knowledge from that. If you could go to the next slide, please. So the goal is, what we are working on is providing technology that analyzes text in particular, for example, from various languages, Russian, Chinese, Arabic, and so on, English as well, of course, and map that out into structured knowledge representations that we can then convert into actionable data in various scenarios. And I will explain a little bit about that later. At the same time, what we are doing right now is trying to come up with new technologies that generate descriptions of content in images and bringing text and images together so that we can identify misinformation, mismatches in the communication, or describe the scenario more accurately where certain information is contained in the pictures or images but not in text, and vice versa. At the same time, we also try to process spoken language and map this out into such knowledge representations. And the difficulties are, of course, that you want to do that for various languages. We have about 7,150 languages on this planet. Majority of those is actually just spoken, not written. And you want to encode there also knowledge about these languages and what people are talking about, knowledge about their cultures, and the real meaning behind what they are saying, and map this out. So this is one of the challenges of these technologies nowadays. Next slide, please. The general challenge for us, what we want to address, is the predicted growth of data that will be reaching something like 175 zettabyte in 2025, projected by IBM Research and Gartner. And the problem is that 90% of the data in this data stream that we'll be have to process one way or the other will be unstructured. So we'll have to come up with technologies that are capable of converting unstructured information into structured and make it accessible for business decisions. IBM was predicting that 90% of the data that any corporation or operation or service has on premises is not processable or analyzed in any way and not part of the decision-making process in operations. If you go to the next slide, please. That's just a summary of what we want to do. We want to basically revert the relation and make 90% of the information accessible. And the challenge is not just knowing how to do that, knowing the algorithms and technologies. The challenge will be having the technologies that can process in real time, fast, high performance with high accuracy and quality, large amounts of data. We are talking about zettabytes just for text, actually, not about image and video and audio. And a lot of changes currently in the internet and in data handling and so on in businesses are going from stored information to streamed information, exactly what we are doing right now with our Zoom sessions here. Next slide, please. So one example, I would be happy to present this to you as a real-time application. We can do that. We have web apps that show how this works. This technology is, you would toss in some text and the text would be analyzed and processed. And we generate something like structured knowledge representations and semantic knowledge graphs that we can then use to summarize, translate, and expand, validate, and make predictions over as structured data. In this graph here, types of things would be encoded with colors. So medications like aspirin is green, and painkillers like paracetamol is gray, and fruit is apple, fruit is orange, and person is blue, and so on. And you see sort of the idea behind that. The operations, the conversions into such structured knowledge representations are highly complex, but we can do that now in real time over one input stream, even for spoken language. Next slide, please. The idea then is basically to link all the details of what people are mentioning and saying and know more about that. Know that Paris is a city in France, know that aspirin is a non-steroidal anti-inflammatory drug, and so on. These bits of information we pull from large knowledge representations in real time, disambiguate them, and we can do that then over multiple languages. What we are trying to do with these technologies is basically to address issues in cyber warfare, for example, cyber attacks using misinformation, something that is becoming more and more relevant and accurate right now, actually related also to the outbreak of COVID-19. There is a lot of propaganda going on that basically wants to discredit all activities in the United States and create sort of discomfort and uncertainty in the population and so on. The people are basically doing this not just now in the COVID-19 problem, but in general, trying to weaponize information and use it against us in various ways. And our approach is basically to create technologies that can basically go into the content and identify misinformation, fake news, and inform people and basically eliminate that from the communication stream. Next slide, please. And we are building, so this is a thing that I would be happy to show you in real time. This is even a mobile phone application that you can use that allows you to speak Russian, Chinese, and various other languages in real time into the system, and it would convert it into an English knowledge representation or knowledge graph, as you see in the a center window, and we type then all the information and explain you what these things are that people are mentioning. We can do that for a lot of languages. For languages that are not yet covered technologically, it takes us about a month or two to come up with basic tools to start analyzing it. It's already helpful actually even for English alone if you're talking about really very specific, domain-specific language that normal people would not understand. So what we can do is basically translate expert language into something that normal people might understand and summarize it and so on. Next slide, please. And I think this is the last one. So just in general, it's about content to knowledge representations. We can convert manuals and documentation to structured, searchable, and semantically annotated information. We can process news and validate, fact check, or check for logical consistency of certain claims in real time. We wanted to demo that on the spoken language interface system. We can aggregate knowledge for use in various other technologies, including autonomous vehicles and devices, robots, for security and cybersecurity checks. We can generate summaries, we can rephrase content so that it's easier to understand for people who are not domain experts and so on. This is basically the back-end technology that we are developing. The natural processing component behind that is spoken language interface to smart devices, autonomous vehicles, and robots, such that you could actually ask them questions and tell them what to do rather than programming it and controlling them over some remote device controller. We can provide customer support help over large-scale manuals and documentation, for example, and allow people to ask questions about that and provide general query answering systems over information sources and content encoded. That's all that I wanted to summarize here. I don't know whether there's another slide. There's another slide. If you, yeah, we can. This is just showing that, yeah, our goal would be to make devices make communication with devices easier and better, and enable basically robots, for example, or even all kinds of vehicles actually to communicate in a very smart way with humans, where sensor information coming in from all kinds of types of sensors and visual information can be aggregated in knowledge representations. And I think that we are now over it. Is this the last slide? Oh, there's one more. We can skip that one. It didn't. I did already all my time. So this is just summarizing again that you get an idea. What all that means is, you know, you have basically textual information. And if you know how this works with human communication, when we search in Google, in the Google Web Corpus for orange carrot, we might not find any hit because people don't talk about orange carrots because everybody knows that carrots are orange. But what we'll find is purple and pink carrots mentioned a lot in text. And you might think that carrots are purple or pink then. But if you take the visual information and see carrots, what they look like, you will see that they're actually orange in the majority of the cases. So this is why we say that we have to bring multimodal input streams together and process information from various sources at the same time and generate knowledge representations that we can then utilize in all kinds of applications. That would be it now, I think. Thank you.
Oh, thank you, Damir. That was fascinating. I think there's a question. I unfortunately can't read it, but I think you can. Anne, could you share that with Damir and perhaps he can answer it?
Sure, yeah, it's from Frank Purdy. He says, how do you accomplish these tasks and what is your capability TRL level?
We have technologies that we develop ourselves. I'm in this business for about 20 years now, and some of my former PhD students here from IU and colleagues who are in this business also for 20 years. What we are doing is we are bringing technologies together that are natural language processing. Some of these technologies to be adapted and tuned. We worked in the domain of coping with low-resourced languages and trying to just fly in native speakers of a targeted language and record with them speech corporation, speech recognition systems, and so on. Our TRL level would be basically some technologies are ready for use and they are robust and stable. They are high real-time capable, in fact, actually, for a bunch of languages, a dozen of languages. And we have the technology and environments to adapt to any kind of language. And it might take then, of course.
Great, thank you.
Great. Thank you. Anything else for Damir? I don't think there's another question. If not, Damir, thank you so much. This has been enlightening, certainly to me, and I'm sure to everyone else. And I'm sure several people will be in touch with you. Next, we have Joel Neidig. Joel is CEO and co-founder of SIMBA Chain. So Joel, please, you have the floor.
Yeah, can you hear me okay?
Yes, sir, we can.
Great. Yeah, so my name is Joel Neidig. I'm the co-founder of SIMBA Chain with my CTO, Dr. Ian Taylor, from the University of Notre Dame. So we were funded from DARPA to begin with in 2016 and formulated the company the end of 2017. And so we've gone on to, you can go to the next slide. Yeah, so here's, we won the commercialization award for Notre Dame. You can go to the next slide. So we won actually a SIBR Phase 3 now. So we've been awarded all the way up to SIBR Phase 3. We have it's a Navy contract contracted through NAVAIR. So the Navy can utilize this sole source solicited award. The first delivery order is $9.5 million, but we have several in the bucket now for $49.9 million. So we have a lot of stuff going on right now. This is supporting NAVWAR, believe it or not, out in San Diego. But we'd love to do more work with Crane, and so we have a presentation here that we'd like to discuss regarding the microelectronics side of things and protecting different devices. So you can go to the next slide. So obviously there's been massive data breaches happening across the world. Our particular technology is using blockchain technology to secure and provide monitoring capabilities to different data streams or data files. You can go to the next slide. So recently there's been a lot of flaws, or particularly in some Intel chips, attackers slip their own data into secure enclaves. And so this is reported at TechCrunch. So we're going to kind of describe, so I have a couple of my developers on the line, architects, to kind of describe what our technology is doing. You go to the next slide. some use cases. Process Stream is a pharmaceutical quality control software platform that is used obviously in tracking the pharmaceuticals, and so they can process our use case with them. We were doing archive files that you need to guarantee that these haven't been modified per the different FDA needs and different things like that from a quality side. So our technology is able to scan terabytes of data at a time and put a secure hash on that file and then secure it so that it, no matter who's modified it or what, it would be flagged. And then so you can kind of monitor as needed and by exception, and not have to kind of like file through all these different kinds of processes. So you can go to the next slide. So we're on slide 7 now, and I want to hand it over to Ian Harvey. Ian, are you on the line with SIMBA?
I am.
Okay, so we're on slide 7, and I'll just say next slide, Ian, when you're ready to move to the next slides.
Okay, great, thanks. Yes, so I'm going to quite quickly talk through the SIMBA chain approach we've got to ADI, that's our automated data integrity system that we've put together. It's an integrity tool that's built on top of our Python SDK, and that SDK is talking to a number of backend systems that we've been building over the last year or so. So fundamentally, this tool is scanning file systems for file changes. So when the file is initially written to your disk or into your file stores, and records a fingerprint onto the blockchain. So I'm going to be using the word hash a lot. This is effectively a fingerprint of the file at the point when it is first stored. So this is a description, cryptographically secure of the file, and so if the file changes, the hash changes. And so if this is stored onto the blockchain, we've got irrefutable proof of the file's contents without having to store the file itself, because, as I say, if the file is changed for any reason, then the hash changes, and the record on the blockchain will be updated to show that. So next slide, please. Okay.
Go ahead, Ian.
So the initial use case that we've got is storing these hashes on blockchain with the aim of creating sort of aids towards compliancy, so that you can sort of prove when files are changing, that they've changed for a reason that you wanted them to change for, or that they've been completely left alone and are secure. So we've got 2 implementations underway. We've got a Azure blob service, which is the demo that we're going to be working through in the next few slides. And there's ideas of doing the same thing around AWS's S3 bucket storage, and really any other cloud server environments where there's demand. Next slide, please. Okay, great. Yeah, so what is it? Fundamentally, we want to recognize changes to data. So data is files, it's directories, it's databases, and with the goal of increasing the ease of auditing or ease of conformance, or fundamentally the confidence that you have in your data. If you have no confidence in your data, then all bets are off, really. Next slide, please. So these are the benefits. In order to do that, we want to detect changes in the data. So we're hashing the files, we're storing these hashes onto the blockchain, and if we hash these files at a later date and compare the 2 hashes, if there's a change, then we know that the file has changed for some reason. Recording these changes onto a blockchain makes it far, far more difficult for anybody to do any sort of illicit activities with your files, because it's incredibly, well, essentially impossible to change data once it's stored on the blockchain. You can be absolutely certain that when something is recorded on there, that you can believe it. And part 3 there is presenting those changes to the user. We need to provide some sort of user interface to display what's happened so that it's nice and easy and accessible to find out what's going on. Next slide, please. So spreadsheet sort of demonstration of this. This is going to be using Azure Blob Store as a demonstration because that's what we have working actually within our own environments at the moment. And I'm going to keep saying the word integrity a lot because that's what it is that we're trying to ensure. Next slide, please. So here we've got a view of the Azure Blob Store. We can see the different containers on the left with files in the main tab. These are the files that we want to be certain of the integrity of. They shouldn't change. They could be anything, shipping details, interview transcripts, medical records, or system files for an operating system. Fundamentally, we want all of these files to remain exactly as we left them. Next slide, please. So this is the data that's actually stored on the blockchain. We can see that we've got a hash of the file, and that's what the hash ends up looking like. So just a sequence of characters, a description of the file path underneath, and the method there says that this is the file's initial hash when we first saw the file, and at the top in green it says deployed. That information is on the blockchain, so once that's there we can't change it. Next slide, please. So some terminology as we go forward. We've got the blob store, which is where all the files are. We've got the hashes of the files, and Azure has the ability to install functions, and these functions are triggered when an event happens. So the event that we're specifically looking for is a file changing in some way, and that trigger is then fired, and we do something with it. Next slide, please. So moving on with the demo, we can see that a file has changed. Normally, when files change within your hard disk, you wouldn't really know that the file has changed unless you're particularly diligent about going and looking at the change dates. So really, we want to perform some sort of action when the file changes. Next slide, please. So later on, when we're hashing the files again, maybe we want to be performing a rescan of the system every minute, every hour, or at the end of every month, whatever is appropriate for the system. And if the file has changed, we can see that the two hashes, there's a mismatch. You see on the screen there that the method says file hash mismatch, and that is also deployed onto the blockchain. So every step of the process is stored on the blockchain indelibly so that we can go back through and we've got a history of all of these events and actions. Next slide, please. And here's the important bit. Once that happens, we want to actually do something with that information. We want to show it either on a dashboard or via some other sort of event, maybe an email, maybe it calls some other server or service, but really it becomes part of your either new or existing data management pipeline. As these files are changed, the information is on the blockchain, but is also telling you and your other internal systems that an event has happened and somebody probably needs to do something about it. So the next slide, Kieran, if he's on the line, is able to take over and give another example of how this is useful.
Hi. So as Ian explains, the SIMBA ADI system, building on top of that, we're looking at Linux firmware. So the Linux kernel has the ability to load these firmware modules into hardware at runtime. So things like CPUs, GPUs, network cards, they've got onboard controllers, and the software is loaded at boot time onto those. These, of course, being directly on hardware, can have elevated privileges compared to normal software running on a system. So if someone was able to modify those bits of firmware before they're uploaded, they could potentially have hooks in the system, giving them vastly elevated privileges. Next slide, please. The only time these firmware files are changed usually is at update, or when the system is updated. Being able to detect changes to these files during or outside normal update conditions allows you to react and take swift action to lock down the machine, such as shutting it down to investigate or locking it from the network and other things. So ADI Linux firmware module would index this firmware at a known good state, cryptographically storing cryptographically secure file hashes on the blockchain, and also taking full advantage of the ADI eventing, alerting, and monitoring system. Next slide, please.
Great. Thanks, Kieran.
Yeah, thank you, guys. Hey, couple questions. We've got a couple of minutes left. 3 are from Frank Purdy. The first is the file, if the file is already compromised, will you detect the flaw when you run your scan?
Yeah, so we're taking it.
Go ahead.
I mean, Kieran and Ian could take this probably, but I mean, basically we're taking a known good state of data, archival data, but Ian and Kieran, I don't know if, yeah.
So the intention is that you run your initial scan on a known good state. So we have to have something to compare to. So if you're running this on a system that's already compromised, there's no way to compare to that. So yeah, as I said, you run it on a known good state, and then you compare backwards from there, moving forwards. So this wouldn't be something you'd run after a breach. This would be something you'd run proactively to try and catch a breach.
Okay, thank you. The 2 others from Frank, and we'll also get to the 4th one real quickly. Have you had a red team test of your SDK foundation? And the last is, what TRL level is your technology?
Yeah, so we are talking with Grim. I don't know if anybody's familiar with Grim, but they do red kind of white hat hacking, and so we're talking with them to start looking into that. A lot of our work has obviously been at the SIMBA level, so we are different stages of our technology. So we are TRL 9 with our SIMBA chain platform, which you can go online, and we have thousands and thousands of developers already on that platform. But the SIMBA chain ADI is relatively new, and so I would think it's really more in the TRL 3 level. It's kind of early days. So, but anyway, that's we do have like I said, we have any color of money for our phase 3 can be used for the advancement of this technology. So I guess next question.
The last one is from Michael McGinnis. He says, question for the SIMBA team. Can you provide the DARPA project they supported and who the PI might have been?
Yeah, so our original phase 1 was with Frank Pound. He's no longer, he was a kind of a program manager at DARPA of I2O. And it was SB 162-004. So that was the topic number, SB 162-004. And I have our Navy contract is publicly available. I can give that to Julie or whoever needs that.
Okay, super. Thanks, Joel. And thanks to you and your team for participating this morning.
Yeah, thank you.
I'm sorry?
Oh, I said thank you.
Oh, well, you'll hear from us again. Next, we have the pleasure of hearing from Jason Kulik with Indiana Integrated Circuits. He is its president and CEO, and IN3 was lucky enough to come up and become acquainted with him quite some time ago. So Jason, thanks so much for participating. You have the floor, sir. Jason, are you on? I'm not seeing anybody heard from Jason on my team. Okay, well, we'll try to get in touch with Jason hopefully soon. Oh, were you on, Jason?
Yeah, I was on via the cell connection and I could hear everything, but when I went off of mute, I guess you couldn't hear me. Sorry.
Well, the important thing is you're on now, so the floor is yours, please.
All right, thank you, everybody. Appreciate the opportunity to present some information on IIC and our technologies. Some of you may be a little bit familiar with us, and a lot of you, I assume, are not. You can go ahead to the next slide, please. So a quick overview. I'll introduce IIC, talk about some of our technology, give some application examples. Some of the images that you see here on slide 2, basically we can package and interconnect chips in a variety of different ways and shapes and sizes and geometries, and there's some pretty powerful things you can do with this approach that I'll get into further in the presentation. Go into slide 3, please. Okay, so Dr. Gary Bernstein and I founded IIC as a spin out from the University of Notre Dame, some research we were working on there. Started out primarily in advanced packaging of microelectronics, but we've been branching out into other advanced microelectronics technologies as well. So in addition to advanced packaging, we're also doing more hardware security and low energy, low power computing things as well. Our business model is primarily to license the technology. So we work closely with customers and partners to help them get our technologies into their systems. And we do a lot of prototyping and fabrication work. So we make real tangible things in the real world. However, we're not a manufacturer of those systems. Typically, we do a technology transfer into whoever we're working with and or their supply chain. We've got a growing IP portfolio. There's about 23 issued US and international patents and somewhere around 16 more pending. The lack of exact clarity on that is because there's a couple things splitting PCT-wise and whatnot that are a little hard to keep track of sometimes. But those patents span kind of the breadth of our technology offerings. A lot of those things we own outright. Some we have licensed the exclusivity piece from our patent co-owners. And we provide kind of a one-stop shop that way. Speaking of a one-stop shop, originally we thought we would do some of this technology development and hand it off to industry, and industry would be able to take it, across the goal line because that's what industry does. However, over time, we've become a lot more familiar with the concept that people want a complete solution from soup to nuts kind of handed to them. So we've been working on establishing supply chain to get our technology integrated. Sometimes this involves working directly with the customers that are vertically integrated and their internal capabilities. Oftentimes it involves working with other foundries and partners. So we do have pretty deep relationships within the packaging and semiconductor space that we can bring to bear on customer issues and problems. And we're based in South Bend, but we have a pretty national reach, in some cases international. Most of the people we team with aren't located in Indiana, though we do have a pretty good relationship with Crane. Go ahead to the next slide, please. From a market perspective, as far as the kind of applications we're in, the quilt packaging and some of our other technologies are basically all platform technologies. So there's different attributes of the technology, whether it's miniaturization or high bandwidth or heterogeneous integration, that have a lot of value to a lot of different applications. So we're working across, things like RF and microwave, power electronics, optical integration, where we can actually align lasers and diodes and waveguides, sensing arrays, biomedical. We're kind of across the board there. The reason we can operate across so many spaces is because our business model has us just sticking to the stuff that we know best, and our customers are the ones that are actually designing and building their chips and systems in these application spaces. So we basically just help them augment and improve what they're doing, and we as IIC do not need to be the experts in everything. Go ahead to the next slide, please. So we're on slide 5, addressing what is this quilt packaging technology that I was talking about. And basically, if you look at the right-hand side of the slide, you see a very simple cartoon that says chip A, chip B. This is a cross-section. What we do with the quilt packaging technology is we create solid metal interconnects that stick out the vertical side of a chip. Allows you to tile multiple chips together, or quilt them, if you will, just like you would make a cloth quilt out of different panels of cloth. We can stitch the chips together at their edges. The reason this is really powerful as a technology is we can do it in not just silicon, but a variety of different materials. And electrically, it performs as if it's an on-chip interconnect. So it's very high bandwidth, very low loss. We can also get sub-micron chip-to-chip alignment accuracy. using this approach, and we can engineer the gap between chips to be pretty much whatever you want. So what this allows you to do is optimize, you can partition your large, poorly yielding chip, or you can partition out functionality and optimize by different semiconductor material, different process node technology, different IP blocks for security, whatever. And when you put the whole thing back together into the quilt, as it were, it performs as if it was one chip to begin with. So you get rid of a lot of the trade-offs from monolithic integration, but you get monolithic-like performance. Go ahead to slide 6, please. So here you see a collection of images. I'll start with the SEM image in the center, the scanning electron microscope. So a lot of times I get questions on whether this is like an epoxy glob or a beam lead or a piece of foil folded over. The top center SEM image, what you see there is on the left-hand side of the SEM image is the top edge of one chip. On the right, it's the top edge of another one. You see a fairly detailed self-aligning quilt nodule, as we call them, structure. You can see from this that it's a solid metal interconnect. It's not a beam lead or an epoxy glob. And we can engineer these to be a variety of different geometries, sizes, shapes, even have different sizes and shapes on the same chip. You're not stuck with a one-size-fits-all approach. If you move to the immediate right, top right-hand corner, now what you see here is a combination of quilt packaging along with through silicon via and thermocompression bonded to a copper pillar carrier. So the top half of the image, you see two chips that are quilted together. You can see the solder kind of reflowed across. The little balls that you see on the bottom half of the image, that's some of the copper pillar array where the quilt was not thermocompression bonded to. With respect to the detail that was in the center SEM image there, you don't normally see that because we apply solder during the fabrication process at wafer level, and it reflows across, as you see in the top right and bottom 3 right images. The bottom left one kind of shows what the electroplated solder looks like before it's reflowed. And then coming clockwise back around up to the top left, you see a quilted chipset packaged in a standard Kyocera ceramic package. So one of the other key concepts of the quilt packaging technology is whether it's 2 chips or many, you treat the quilt as if it was one large chip to begin with, and then you go ahead and put it into a package, onto a board, whatever. Go ahead to the next slide, please, and I can speed this up a little bit. Our go-to-market, we have, as I mentioned before, a variety of supply chain partners, typically on the defense side, and this is the same on the commercial side. There's design requirements. Us and our partners and customers will get involved in the analysis and the design. Fabrication will happen at a front-end line foundry. Sometimes they'll do the whole process. Oftentimes we'll pull the wafers out and complete them at the back-end line fab, and then there's several different options for getting the quilts made assembly-wise. Go ahead to the next slide, please. So slide 8 has some microwave data. I mentioned that we're very high bandwidth, low loss. So from DC across the entire bandwidth to 100 gigahertz for about 1/10 of a dB insertion loss, all the way out to 200 gigahertz, we're still well under a dB. This is just snapping the chips together, and again, we can do this in a variety of materials. Go to slide 9, please. One of the projects we have related to Crane actually at the moment is we're doing some statistically significant sample sizes and testing with DoD and Defense Industrial Base input and partnering to raise the TRL MRL for the quilt packaging in RF. Go to the next one, please. One of the other key technology areas we're seeing a lot of growth in is this Air Force Research Lab invented hardware security protocol. We're currently funded under one of the MinSec programs with the AFWERX Microelectronics Challenge. Basically what this approach does is it uses quilt packaging to put together secure and unsecure components. And the way this hardware security protocol works is that you can design and have fabricated the unsecure chip anywhere in the world that can be completely infested with hardware trojans. But once you assemble it with the quilt packaging interconnect, that it attaches it to the randomizing coding template. And again, you have to design these 2 pieces together, but the trojans are basically rendered inert. Go ahead to the next slide. In addition to the coplanar approach, we can do a variety of different 3-dimensional things, and we can also use the quilt chips themselves kind of as miniature printed circuit boards. So here you see some orthogonal integration. This is kind of a departure from what you normally would hear of. Standard 3D integration involves stacking, but we can actually very precisely arrange these things at different angles. Go ahead to the next slide. From a power electronics perspective, we're getting a lot of traction in that area as well. A lot of the same value proposition as with the RF materials, in the sense people want to get rid of parasitics. They want to use non-silicon materials tightly integrated with silicon materials. We can engineer our interconnects to be basically miniature copper bus bars and push a lot of current through them. So we got work going on with some auto OEMs and Department of Energy on that. Go to the next slide. I mentioned the low energy computing. We've got another program that involves a 16-bit MIPS microprocessor. This is moving to phase 2 to verify all the design from phase 1, but essentially you get 80% power savings and some built-in resistance to side channel attack. Go to the next slide, please. We can also do other unique curved, three-dimensional things like curved focal plane arrays. We're about to start a program on that. Go to the next slide, please. I mentioned we can get submicron alignment of these chips one to the other, so you can actually do passive alignment for optical coupling chip to chip. You don't need a bunch of extra optics, and you can get many channels snapped together instead of active alignment of one channel. And I realize I'm starting to run long, so just go to the next one, please.
You got
finally,
3 minutes, Jason, go ahead.
Oh, okay, great. Finally, we related to the record Air Force invented security protocol that uses quilt packaging that I mentioned earlier. We had started exploring how to expand that into PCB and do quilt to PCB integration. And we've got some preliminary studies and work going on with SAIC and Crane as far as extending the security approach and the quilt packaging approach to PCBs. So we're doing boardlet integration and things like that, which will potentially eliminate the need for a lot of the really expensive higher end PCB to PCB connections. And I think the last slide is just my thank you and wrap up slide. So again, I know I went through that very quickly, but I was trying to just give folks an overview of the application spaces we're working in case that's of interest to people on the call here. Quilt packaging is very flexible technology. It's very wide bandwidth, low loss. We can implement a variety of different materials. We're working in a lot of different spaces that bear on defense. Probably 70% of our interest in business is defense related, but the non-defense piece keeps expanding, which is good for everybody. There's a slide at the end that you don't have to show that relates to the fabrication process, but we don't have time to go through that. I just always include that in case a specific question comes up. But if anybody does have any questions, please contact me directly or get a hold of me through the IN3 folks. I really appreciate the opportunity to present this. Thank you.
Jason, thank you. Terrific job. I think everybody had the pleasure of learning a lot. I certainly did. I don't know that there are any questions. I don't see any at the bottom of my screen. So if not, Derek, can you move to, there we go. Okay. Again, thank you, Jason, very much. Next we have Jeff Bold and David Sharman. They are with Transhield. Jeff serves as Vice President of Industrial and Government Business Development, and David serves as Transhield's Military and Technical Advisor. So, gentlemen, you have the floor. Jeff, David? Derek, can you tell if they're on, perhaps?
I'm checking, but I don't see their name anywhere.
Jeff says that he is trying to talk through the phone. Is he muted somehow?
Yes, every phone call in is muted right now. Let me check.
Thanks for your patience for everybody on the phone and online. I know that this is a little bit of a challenge, but you know, honestly, I'm really pleased with how things have gone so far, particularly given the various challenges we all face. So if you'll just hang with us for a minute, I'm sure we can get this back on track. How about this?
Can you hear me?
Oh, there we go.
This is Jeff. Can you hear me?
Yes, but we're getting some reverberation. So can somebody mute their phone? So Jeff, can you still speak with us? I think we can hear you. Now we can't. I'll tell you what. Did I hear you guys or no? Yes.
Okay. I think you're hearing me through my computer now, right?
I am. Yes.
Okay. There, I muted my phone. I think that takes care of the echo.
Yep. That's great. Okay, go, please. Thanks.
Okay. I apologize. I'm having some audio difficulties here with my computer, but we'll get started. We're on the first slide, and a little bit about Transhield. We're from Elkhart, Indiana. We were founded in 1994, and we have a number of material technologies that have been patented that we turn into customized covers that are utilized in the defense industry, in the wind energy industry, in the marine industry, and they protect from various things. They're anything from a shrinkable material to a day-to-day cover, and we've been, I guess, doing that now for 26 years. We're well grounded in the DoD. We have over 220 national stock numbers on those items, and our government business or defense business has grown dramatically over the last few years. This is probably kind of interesting because I know Jenna Dix spoke about a CRADA, and this technology we're going to discuss today is the result of a successful CRADA in conjunction with the Navy Surface Warfare Center at Port Hueneme. It's been taken all the way to TRL level 8, and it's been a great experience for our company to do this. And if anybody has any questions about what working in a CRADA environment is like, please feel free to contact myself or Dave Sharman, and we'd be more than happy to discuss it with you. The guys at Port Hueneme have been great to work with, and we were able to develop a kind of unique product very rapidly because of the flexibility that a CRADA provides. So go to the next slide. So what's going on, particularly out in the Pacific, is that the U.S. Navy, on a daily basis, is being inundated by people using RF energy in the radar bands normally to interrogate the ships and the items when they're in port, particularly the assets that are on the deck of the ship. The high-tech radars, the high-tech antennas, the high-tech weapon systems. They integrate those, and they're trying to figure out what the capabilities are. And we are told, we don't have the security clearances, but we are told that at times they're able to use this RF energy to affect the capability or alter the functioning of these items. So it's pretty hard when you come into port. I don't know if any of you ever deployed on a Navy ship. I spent 3 years on one, but when you come into port to perhaps build a steel cage around your antenna or something like that. So They were looking for a new, easy way to protect these items while the ship is in foreign ports or even in friendly ports, because of these people using the radar devices to try to figure out what's going on with our assets. Next slide.
Hey, Jeff, I don't mean to interrupt you midstream, but just a reminder, this is all for public information.
Yeah. Oh, yes. That distro D statement, that's a mistake. It carried over from another slide presentation with additional.
Okay, all right. Just wanted to make sure. I knew we'd had that conversation, but just wanted to. Okay, go right ahead. I'm sorry.
Yeah, I'm sorry. I couldn't hear you, and now I can. Yes, the distro D statement is my fault. I didn't remove it. It was a carryover from another.
That's okay.
Another presentation,
please, right ahead.
And this is all open source. So.
Yep, we're listening intently. So please go ahead.
Okay, thank you. So to address the threat, we'd gotten to know some of the people at Port Hueneme over the years, and they approached Dave Sharman, Dr. Dave Sharman, and asked us if we would be interested in trying to develop a cover that could block this RF energy. And of course, we were interested, and so utilizing their expertise and our expertise, we were able to put this together. This slide just kind of shows what we brought to the table and what they brought to the table. They're the experts out there on ship signatures and things like that, and we're kind of the experts at being able to take a whole bunch of different types of material and figure out how to add it all together into something that solves a problem. The CRADA number is at the bottom of that slide, and we entered into the CRADA about 2 to 2.5 years ago now. So this is in the defense world, this is a pretty rapid development. Next slide, please. Again, the focus was to limit the malicious RF scanning that was going on. You can see a couple of the covers that we've already developed there. Limit the ability to determine the geometry or what it is, and we call it open base surveillance, like in the shipyards and things like that, where there's just a lot of sensitive things sitting around. Next slide. The results were, oh, back one. Oh, forward. Thank you. Right there. Yeah. Again, they provided the expertise on the RF shielding side of it. We were able to take their expertise, turn it into a workable cover. You saw a picture of the covers, and they actually look exactly like the standard anti-corrosion covers the Navy uses. So that's kind of an added benefit. This was tested extensively at Port Hueneme, then at SPA in San Diego, which is now the Naval Information Warfare Center, and then at the Naval Surface Warfare Center, Dahlgren. Next slide. Now the results, it's a lightweight cover that significantly reduces the ability of RF energy to penetrate the cover across the common military radar bands from 1 to 18 gigahertz. More than that, it can be used to develop different shapes, make something look like it isn't, or make something look like something else. And a follow-on that we're going to do with Port Hueneme is going to be exploring that further here come later on this year. And the biggest thing I think that Port Hueneme is very concerned about was the cyber-induced electronic infection or alteration of some of these assets. And again, we don't have the security clearances, but if anybody has a security clearance and would like to talk to Port Hueneme about that, we can put you in touch with the right people there. Next slide. The benefits, they're lightweight, they're easy to install. Again, they have the same look and feel as the existing NAVC anti-corrosion covers that we provide to the Navy already. So in addition to the RF shielding, it also provides that protective element. We were able to develop this RF shielding cover and maintain the anti-corrosion capabilities within the new material. So they're looking at it as a kind of a 2-for-1 deal. They can use one cover for everything, and it's very cost effective. It's a fraction of the cost of trying to build a steel cage or getting radar absorbing tiles or radar absorbing tile covers and things like that. Next slide. The recommendations on the final CRADA report, and if anybody would like to see that, we can send it to them, is that this should be utilized on all topside assets while USN ships are in port. Port Hueneme is investigating developing NSNs for certain covers that they've identified that are critical. And we're going to conduct some underway trials to see how well it holds up when the ship's doing 20, 30 knots across the ocean. Other potential applications, I already mentioned we're going to explore the idea of deception and decoys and altering ship signatures with Port Hueneme later this year, and in discussions with other services protecting multiple launch rocket systems, F-35s, satellite communication terminals, anything with a high-tech type package inside of it that might be altered is getting everybody's interest. And we're also, from the ground forces, we're getting a lot of interest in deception and decoys and things too. Next slide. This is just an overview of the number of covers per ship based upon Port Hueneme's assessment of what should be used. We've already developed, I believe, 2 or 3 ship sets that Port Hueneme is going to start utilizing as ships come through their port there prior to their deployment to the Western Pacific. And I know they're casting about for funding for expanded use of this technology. The next slides just go a little bit more in depth on the testing. And that slide is just a little bit about Transhield. I already talked about that. Please go forward again. And one more. And if Dave Sharman can get on, he can talk a little bit about the testing on the next 4 or 5 slides.
David, are you on?
If not, I will do my best.
Go ahead, Jeff, until we can get David, if you would, please.
Okay, next slide. As discussed, there was 3 rounds of testing. The first was at Port Hueneme, and it was just done on one radar band, the X band. And basically, it was compared to a plate of steel, and they transmitted and bounced back the signal. And go to the next slide. And it basically showed that the cover was working as well as a steel plate to block the RF energy from penetrating. So that got everybody pretty excited. So we did another round of testing down at the Navy Information Warfare Center, or SPA-WAR. So next slide. And this was basically a broader band test across the across 3 frequency bands, and again, it reflected very, very well. And these were done with lab samples, so we went into a small production run, and then we took it to Dahlgren. Next slide. This is again just showing that high reflectivity across those 3 bands. Next slide, and then we get into the Dahlgren testing. So at Dahlgren, it was a more thorough test. It was done across the entire radar spectrum, 1 to 18 gigahertz, and it tested how much went in, how much could come out, and it was done from all angles, and it was again quite dramatic results. Next slide. Across the bands, it showed high reflectivity across all frequencies, and you have to remember that. What that slide represents is that it's blocking say at the 8 gigahertz, it's blocking 40 decibels worth of RF energy. And then anything going through the cover is also getting blocked on the way back out. So it's actually 80 decibels. We're trying to figure out a way to portray that graphically better, but this is all still rather new. We just completed this about a month ago, and we're just now getting to show it to everybody. And I guess that concludes the presentation. Again, I apologize for the distribution D statement. I should have removed that. I carried over from another presentation that had more information in it. This is all open source, and you can spread the good word about this to everybody you can.
Jeff, this
And
has
we
been
really
absolutely
enjoyed being able to discuss with Crane today, because already a couple of the systems that we are targeting to use this technology on the ISEAs are at Crane. So thank you very much. And again, I apologize for the technical difficulties.
No, that's quite all right. We expected some of this, and we've got about a quick minute here before we have to move on, but I do have a couple of questions. Well, actually 3. So one is, can you give a good point of contact at Port Winnie? This is Jeff?
Yes, we can do that. His name is Alan Yeager. And if you can email me, I think I was on the email chain, and we can get you his point of contact. He's been great to work with.
I'll share everyone's contact information, Jeff. Thank you. Another question is, did the Dahlgren testing include various weather conditions?
No, it was done in an inside chamber.
Okay, and then there's another one. It says, for the covers, I would recommend performing testing on how flammable they are when the sailors forget to remove them and activate the EW system or other emitter they are covering. Need to confirm what type of extinguishers are needed to put out fire as well.
Yeah, that's a very good point, and that's been done with our anti-corrosion covers, and we don't think it's going to be any different. But again, there is some training that has to take place when you're utilizing a cover technology like this, and there is more shipboard evaluation that will be conducted over the next 2 or 3 months.
Perfect. Thanks, Jeff. And please apologize to David. We had a few little glitches here, but would have been a welcome participant. Next, we have Gary Danner, who is the CEO of Danner. I ran across him with a couple of my Crane colleagues in San Antonio a couple of months ago, and was delighted that to make contact with them, and so happy, Gary, you could join us. So please, you have the floor, sir. Gary? Derek, can you tell if he's muted or? I heard something. Gary, are you on?
Yes, I'm on with you.
Oh, terrific. Yes, we can hear you.
Hear you.
Please go ahead. We had a little technical difficulty, but you have the floor.
I was hoping so much that was going to go smoothly there, but happy to be part of Zoom and with everyone. I know it's an interesting format, but we're excited to be here. And as you may know, we've actually done a lot of testing of our equipment batteries out at the Battery Innovation Center at Crane. So we're an Indiana company. We started 10 years ago, and it is full of technology, and we're happy to be here in Indiana and being part of today's presentation. So I'll get right through this. The first slide that is up is certainly an off-road vehicle. That's my background of 35 years of working with off-road work machinery with the defense community and construction and agriculture. But we saw an opportunity that the platforms and the equipment of off-road was going to be moving away from internal combustion diesel engines. So we've been under the radar, so to speak, for 10 years, developing the concept vehicle, and through different generations of prototypes, we actually put our Generation 3 into service about 2 years ago, and what you're looking at is Generation 4, which we started deliveries of that to the public just last year. So the next slide really kind of shows the direction and the why of the product. It really is about work, a different kind of work. There's really only two numbers on the slide I would have you focus on. That to the left, there says 250 plus. That means 250 attachments that have been in the marketplace from people like Caterpillar, John Deere, and Bobcat that are commercialized, reliable. This platform was designed to receive all of those. We have some of our own attachments that go onto the platform, but the idea is that you can take an electric platform like this and receive other work attachments that are already perhaps in a fleet manager's inventory. The right side, the number there shows 500 kilowatt hours of usable electricity per machine. And this is scalable, meaning not everybody needs that much. So the machine was designed, and we've got great engineering partners with BMW for batteries and so forth, that we can scale this up from 125 kilowatts all the way to 500 kilowatts to have the right amount of power on board. The next slide really kind of makes the point that going forward, what is happening in transportation and in the off-road equipment is we're all moving towards a new architecture, if you will, a new architecture that is about an electric platform, being able to carry the energy with us, but being able to use that energy in a connected way. So the next slide shows that the concept of having a platform has been envisioned for a long time. This slide actually kind of goes back to the year 2013, if not before that, when General Motors introduced the Cirrus, and this is really a hydrogen fuel cell electric vehicle, very large vehicle, but showing that if you develop a powertrain that is electric, it can be silent and quiet and not much of a heat signature, but a universal platform that you can do whatever you want. The next slide shows that even currently, this is the Atlas pickup truck that is being commercialized. This is a real platform. It's obviously smaller than the Cirrus, but it's larger than a normal pickup. And the idea is that, you know, with an electric battery, and that gray center there is all battery. That's 14.5 inches deep. It's 500 kilowatts right there. But the idea that Atlas is promoting is they can come to market with a pickup truck, but they're offering this platform to any other manufacturers in off-road or transportation. The next slide shows that Volvo has been working on this for a while. This is not concepts. So these are actually working autonomously up in Finland and Sweden area, in quarries and mining. But the idea of having an all-electric platform that you can do whatever the application would require on top. In this case, it's an automatic dump. And just to kind of bring it full circle, the next slide takes it all the way down to the Volkswagen platform. This is their new ID3 car that's in production. They're planning on making 300,000 of those this year. And just like the others I've mentioned, the concept that Volkswagen is promoting is that this platform will have up to 5 or 6 different types of car bodies on top. And they too are offering this platform to any car manufacturer or anybody that wants to start with the platform. The next slide finally gets us back on track regarding the mobile power station. I just wanted to make the point that having an electric platform is the architecture that Tesla, transportation, everybody is going down, and it makes sense for work machines like ours. If you see on the right, there's a cab. So you could plug the cab in as needed, could be seasonally used or even job by job, or it can be remote control. The next slide shows that the vehicle was designed so that it was very user-friendly, even though that wireless control is a 1 mile encrypted controller. But because this vehicle would be used by emergency responders, we want it to not be intimidating. We want it to be in a form factor that somebody can grab a hold of and can intuitively, very quickly figure out how to move the vehicle around. Now, you can do that with the cab as well. The lower picture shows the mobile power station there with a cab. But Muncie Robotics Club participant, I'm not sure how old he is, but he certainly knew how to grab the controller and drive that machine around. So if we go to the next slide, it's really not new challenges. The truth is we've had these challenges for a long time, for decades. But what is becoming clear, if you look at the far left, deteriorating infrastructure. We've been tracking this for truly a decade, and shovel-ready jobs identified the fact that we're about $2 trillion behind in infrastructure maintenance. So we have roads, bridges, water systems, sewage systems, communications. We've got a lot of work to do. But it's not just that, it's obviously our electrical grid. And I'll just make the point quickly, if you look at the right side of the slide. When we think about infrastructure and utilities, water and sewer and that type of infrastructure, over the years, you know, that service per capita has been somewhat predictable and is growing with the population. The exception to that is electricity. Our electrical grid is having demands placed on it far greater than what was anticipated 50 years ago or 30 years ago. And so electricity and looking at solutions to have support to the grid and try to build in more energy resiliency, that is a tremendous amount of focus, and that is exactly where the mobile power station is focused on, is the fact that distributed energy, having a piece of equipment that can show up and help support a grid or actually provide services off-grid is very important. So the next slide, I'll go through 3 slides very quickly. Obviously, when I say public works, it means any geographic footprint of public space. It doesn't necessarily have to mean it's a city, a county, or a state government. It could be an amusement park, a commercial industrial park, could be a resort. Any large footprint that has a lot of public access to, they have infrastructure. And the mobile power station is designed to show up and be able to do work, but also to be able to support. The next slide makes that point that wherever you have a large gathering of people in a geographic area, it's the infrastructure maintenance people with equipment that are usually the first responders when an event takes place. And so the mobile power station can be working in the morning, but responding to an emergency in the afternoon. More importantly, the next slide identifies the fact that a mobile power station can be configured as you're looking at it here with 500 kilowatts per machine. Never before has it been so easy for a fleet or an agency to be able to distribute energy quickly. So energy can be mobilized, put in an area that perhaps the grid has gone down or perhaps there's no grid to begin with, and you can start tethering these together and becoming the backbone, a very solid backbone of a microgrid that has been established. So what you're looking at is 1.5 megawatts of electricity. That is, the next slide shows that's where we have been focusing our last 10 years of work with suppliers like BMW, Parker, and Cummins, and Dana. These are are solid global tier 1 type suppliers that have great engineering engineering departments helping us out, and we have been focusing on having a very smart connected vehicle that is able to deliver electricity. And the next slide shows what that can look like. The sides of the machine can be configured to have different types of electricity, AC obviously 110 or 220, and different types of charging. We are able to charge cars with the mobile power station, and also be able to recharge with the DC fast charger. So different charging, both inbound and outbound. That's the idea of being able to take a vehicle and configure it in a way that it can collect energy, store that energy, and then give it up at the same time. The next slide, I'll just quickly make the point of 100 years of off-road equipment. We have basically turned 180 degrees around in what has been the convention of work vehicles. It started, of course, with vehicles to do a job. The invention, the apparatus, was very single purpose. You would design something to plow the ground, plant, harvest, excavate, trench, whatever the construction or agriculture was. And the energy required would be put on board with internal combustion diesel engine. Today, the future shows that we really start with focusing on the platform, focusing on the energy and how to use the energy, four-wheel drive, four-wheel steer, remote control, a semi-autonomous. Focus on the platform first, get that right, and then utilize all the work attachments that are already in the marketplace. You can receive those attachments, both ends and both decks. We have a short video, the next slide, if it will play for you. And if it doesn't, I invite you to go to the website and you can see that, and that's exactly what is happening here. The first one that's going to play just shows you some concepts, and what's interesting is these concepts might look familiar or they may look totally brand new, and that's what you can do with a platform. Is we have delivered a couple machines, for example, that have a forklift on one end and a dump bed on the other, just as you see there. So you can envision your own configuration. And so the vehicle is for planned events, events that were unplanned. And this next video, we'll go ahead and play that to the right. It's about 30 seconds. You'll see that this is what a fleet manager can do season to season or job to job. Configure it with operator on board, without operators. And then here's the 250 different attachments that fleets can start putting on. What this really accomplishes for fleets of off-road equipment is the fact that you can now have increased productivity and increased utilization. I appreciate the support staff there of being able to play those videos. I know that's tricky, but
we're a little worried about that, Gary.
No, you pulled that off beautifully.
Well, we've got a pretty incredible team member here, but one quick question, and we're out of time, but if you could answer it quickly. The question is scaling their power station to enable sourcing 480 VAC3 phase within their future plans? Can it be used while charging? And what is the input power required for the charging station? What's the time required to fully charge? That's a lot of questions in there, but if you could answer them quickly, please.
Yeah, a couple that I can answer quickly. We have onboard charging that can receive 100 kilowatts per hour. We're working, and this summer we'll have 250 kilowatt hour charging capability. So if you were out doing work and did 100 kilowatt hours of work, you could charge in 1 hour. or you can charge. If you had the 250, you'd charge in 30 minutes. So the opportunity charging of being able to replace a day's work either overnight, it depends on the charger you have, of course. A level 2 charger, which would be fine for a lot of people, would be overnight charging, to answer that question. And the couple of the questions to try to answer with one answer, the configuration of being able to tether these together and hook up to a cell tower or hook up to a gasoline station, or we can power one house for 17 days, whether that's 483 phase, we have that ability to package and assemble the machines to accommodate what that priority is.
Okay, thank you. Hey, we've got another question, but in the interest of time and trying to keep us on track, whomever asks that question, I can guarantee you we will respond to that in very short order. And we are capturing all of these, so you will receive a response. But in the meantime, Gary, thank you so much for joining us and being part of what we think is a pretty important day. So next we have David Augustine, who is Senior Vice President of Strike Industries. David?
All right. Can you hear me okay, Julie?
Yes, sir. We certainly can.
All right. Well, hey, thanks for the introduction there and the invitation to present today. Next slide. Much like this organization itself on the Naval X, Midwest Tech Bridge, some of your works organizations, DIU, you name it, it's all about finding the new and novel, the disruptive technologies, and rapidly bringing them to the warfighter. And that's what Strike was created to do sometime about 5 years ago. So I'm very excited to be here today. We have a couple of our teaming mates. One you see in the lower right corner is Water. Water is over 50 intellectual properties, patents that have already made it through. We are teamed at the hip with them up here in Fort Wayne, Indiana. And also you see Intel on the slide as well. We're teamed in a strategic partnership with Intel of taking the technology I'm going to brief you today globally, in fact, beyond just DoD. So I'm going to talk about C. So really when data security matters, you'll look at these, and it's a hardware technology that prevents the exploitation and data theft. And I'll talk about those capabilities as we walk through. Next slide. So I consider the security environment kind of the Wild West, and some of the slides that have already been presented. And by the way, some of the companies that are on the line, I'll definitely reach out to you. I think there's some strategic relationships we can have together just listening to your technology. But the Wild West is, you're in a zero trust environment. You got viruses all over the place, malware, spyware, et cetera. You got Chinese chips on boards. You got bad supply chains. You've got encryption systems out there that are on your laptop that you're probably using right now that have been broken many times. And so we've kind of built a lot of our security around castle and moat to where you've got this beautiful castle out there. It's protecting your data at rest. You got this huge moat around it, and then you're lowering the drawbridge up and down all the time throughout the day to let data come into it. And really what we've got is, you got the data theft, the nefarious actor sitting inside your castle. And so what SEAS addresses is the fact that you can have that nefarious actor sitting on that computer today, and we're going to prevent their ability to exploit data for the United States and other commercial agencies in the country. Next slide. So here's SEAS. The depiction you see on the top there, we're actually under an Air Force OTA program. It's being red team tested as we speak. The technology you see there's about the pack of a deck of Hoyle playing cards. And what we were challenged to do under this prototyping technology is prevent the theft of data from our defense industry. Our defense industry is being pillaged. I certainly read articles across all the services to include even the U.S. Navy. And we got to stop it, right? Because when the nefarious actors get to our intellectual property, they can put it in their technologies and exploit it against us. So that's the technology that's currently being red team tested. But to go into SEAS a little bit, it's a hardware agnostic plug and play encryption. So it doesn't matter what OS you're working under, whether it's Windows, Linux, whatever. It's a plug and play encryption that you can put it right on top of it. For the case of the Air Force and the defense industry, they wanted to be able to put this small device alongside your laptop, plug your laptop in and being fully protected, or put it in your pocket, hook up your iPhone or your PDA and be fully protected on the road. So it's really not just agnostic against operating system, but different technologies as well. We think it's the ultimate security for data in motion and data at rest. Inside this module, you can manage all security classification levels to include even coalition forces. So you could have unclassed, you could have your NIPRNet, your SIPRNet, JWICs, and whatnot. You could also parse it out to, no foreign whatever the requirement is to protect your coalition assets so they can get to the data they need, but not to data they shouldn't be getting to. We believe it's quantum computing resistant. We believe when quantum computing technology achieves the number of qubits required to hack AES, it's going to take another 7 to 10 years before they'll be able to hack once the SEAS technology here. So we think that's very important based on some of our adversaries out there. The SEAS technology is based on password hopping. So this technology inside of here can password hop in laboratory settings up to 400 times a second. And so there's just a bunch of different applications, and I'll try to wrap your hands or your heads around that as we walk through some of the additional slides here. 100% definitive authentication and verification, even machine language. You have 100% authentication and verification of the data that's getting into your computer. Dynamic salt. So if you sent David Augustine, my name, as clear text to the system, it would look one way. And if you sent it a microsecond later, it would look totally different. So no message looks the same out there as we send it through the system. We've got an amazing proprietary random number generator. Right now, for the Air Force, we're generating keys up to 2,000 plus bit encryption, but we can go way up in there. It's self-healing mesh network, so it's a beautiful thing whether you're applying it to a warfare, maybe an aircraft carrier warfare group out in the Pacific, or you could apply it to the vehicles sitting, your digitized vehicles, connected vehicles, and sailors, right, on a base somewhere in the world itself. And it's AI-generated violation alerts. So no longer, when you use the SEAS system, do you wait 90 days and say I've been violated by whatever peer adversary out there. You get real-time violation alerts on it. You can real-time see when you're being violated by nefarious actors, whether it's a nation state or not. Next slide. So here's a little bit of hardware. I kind of showed you the SEAS modules that we put together. It's being red team tested with the Air Force right now. Right below that is a mil standard type of ruggedized connector that we're looking at to apply to different other defense technologies as well. I talked about kind of the AI validation of real-time violation alerts. So the SEAS management console we have, very user-friendly. You can manage RBAC controls or rules across the modules themselves. The modules themselves, once you put it onto a system, they don't require configuration management. But you can real-time see when somebody's doing a denial of service attack or trying to play in your backyard. So you can defeat that immediately. It's defeated by the module itself, but you could determine really if you wanted to do offensive type capabilities, if you were at a DoD agency that could do such. And then certainly you're connecting it to a dependent application out there. And let me go into the next slide and I'll talk about those. So this is kind of the landscape that we're dealing out there. You got the commercial, your tech transfer type of landscape, which included everything. We certainly have addressed the defense industrial base. That's what we're doing up at the Air Force right now at Hanscom. And then you've got the Department of Defense and the federal government down there. Next slide. So next slide. Since this is certainly a Naval X Midwest tech bridge, what I tried to do is apply some applications to the defense agency, specifically the Navy. So let me start on the top there. So on SEAS itself, so you could, new generation UAV, UAS type of platforms out there, you could, secure streaming video and secure data links with SEAS. Looking over the Gerald R. Ford class carrier, it could be the newest carrier, it could be the oldest carrier, it could be a submarine, or it could be a legacy destroyer out there. But there's all sorts of things from satellite to ship to flight line ops to the sailors out there launching airplanes, or to trying to protect pumps and controllers and power devices and everything on the ship. The challenge that the Navy faces right now is when you look across a ship, it may not be the newest class carrier, it may be a legacy destroyer. And how do you protect, pump controllers and different things like that that have no intellectual type of IT technology on it, how do you protect that? And so you can protect it by using SIES modules. On the bottom, you can see kind of the desktop laptop. That's kind of the environment when you're looking at protecting the defense industry I talked about. But one benefit is this encryption over encryption. It doesn't matter what you have on your system, and it doesn't matter what encryption you have on your system. So a very powerful capability of SIES is I can take that AES-256 that's known to be hacked, and now I can put 8,000-bit encryption with the SIES module on top of it, and you're going to get formidable encryption that nobody's going to really break through. As we talked about in the middle there, you kind of get the real-time threat visibility and system health of the fleet. And that doesn't matter if you've got 5 modules out there or 50,000 modules. You can go out and you can protect your network operation centers, both DIT and DAR. The speed of encryption is considerable and your data confidence goes up. Or maybe you go into a command operation center or an air operation center where you have naval personnel in, and now you try to exploit the capabilities of Wi-Fi across the entire op center. Or again, we kind of talked about that multiple levels of security with coalition assets and whatnot within the operations center. Next slide. So this is kind of a commercial slide, but really when you kind of look at 4, and there's multiple, right? I could have thrown banking and financial and everything else up there as well. But when you look at protecting using SIES to protect a sector of what you got going on, it's very powerful. So you know, the Navy's got everything afloat, and every one of these things that you look at here on the slide is afloat, right, of an aircraft carrier, and you also have naval basing out there as well. So I'm just going to kind of walk around, you know, how to SIES to apply. So we kind of talked about the transportation systems, right? So you've got aircraft carriers and destroyers afloat, and then you got maybe digitized fleets of vehicles that you're trying to protect on the naval bases themselves. But SIES is a great application to it. When you start to look at industrial IoT systems, this is really a critical need across the every one of the services within DoD, let alone protecting the individual nodes that are very important on a carrier. Now you start looking at your basing itself, and you've got all of your controllers out there that are programmable controllers. So, you know, do you really want a nefarious actor getting up and being able to change something that should go to 20 PSI and change it to 2000 PSI, blowing something up in your facility? Or maybe it's, you know, changing something that should be 115 degrees and they dial it up to 500 degrees and destroy your equipment. So there's a lot of considerations out there. And oh, by the way, like some of your ships, some of your bases, they're very legacy materials out there as well. So you're trying to protect something that may have been created 30 years ago, which is the beauty of SIES. Going over to the healthcare systems, it could be your naval record systems as well. But it's a very, very capable system when you're looking at, you know, trying to protect from the nurse's station out to the sailor that just got operated on, and he's got different, you know, heart monitors and physical monitors out there you're trying to protect. And then you can go up to your energy and smart grid systems as well to protect those. And by the way, a lot of your smart grid isn't so smart. And so by putting SIES against legacy and new applications, you can ensure that no nefarious actor gets into your smart grid. Next slide. And so a lot of the information to digest, and what I'd like to do is any type of technical questions, we'll leave that to go offline with your independent companies or the Navy itself, since we got different individuals on the line. It's much proprietary, some of the things we're dealing with. But you can clearly see it's service agnostic, it's industry agnostic. It's as good for ships and legacy applications as it is for new applications on a naval base. It's hardware agnostic. It's really the only way that we saw that you can fully protect your system from adversary attack. We can go up to 8,000 bit plus encryption if needed. It certainly protects your technologies that you have from digital theft. We never expose anything to anybody out there. And you can see via management console, you know, real-time protection going on. We're all about the Wild West, so take the most damaged system out there that has the Chinese, the Russians, and everybody playing in it, and go ahead and take our technology and place it on top of it. And we'll go ahead and we'll clean things up for advanced persistent threats, malware, phishing going on. And certainly we'll eliminate side channel attacks. We're very robust in our encryption. We have proprietary random number generators. Again, there's not a message out there that looks the same when it gets shipped out. So it's, if you're lucky enough to find the message, Dave Augustine, go out on the internet, and you try to put it back in, it's no longer applicable because the next message that comes out exactly with my name on it will be different. We do definitive authentication and verification. 100% of what goes through your system is authenticated and verified to include all your machine traffic as well. So we know it came from a trusted actor, and it should be on your system. And again, it's a self-healing system, so you could pull modules out and things will work normally, right? So you could you have this huge, peer-on-peer competition in the Pacific, and one of the ships is lost or whatnot. Even though the ship is lost, everything is going to function normally because it's mesh network. And again, I think something very important in the future is its ability to be resistant to quantum attack, which again we know is being investigated and studied with some of our peers out there. Next slide. So there's my contact data that you can use to contact us at. Again, would love to get into dialogue with some of the companies that have already presented. I'll reach out to you as well, and certainly get in one-on-one dialogue with the U.S. Navy. I'll look at some of your questions here, and the ones that I can go on to and give you some more clarification. I certainly will. So Frank Purdy, by the way, greetings. Frank and I worked together on looking at some technology about 5 years ago. So the devices, they are tamper resistant, and that's what we've got produced for the Air Force right now. The validation testing, once the Air Force has already done their blue team, their red team testing will prove what I'm displaying and talking about today is the inability to break in to any of the C's protected nodes. Who in the Air Force are we working with? We're working with Hanscom, the crypto folks up there, under a OTA program that's just wrapping up. And we're in discussions with a lot of different services as well. The unit cost per scale, certainly things change based on the application you apply it to. Environments that the Navy has on ship, require, sea spray resistant and different things. Very ruggedized for vibration. A little bit different for the U.S. Army and a little bit different for the Air Force. Again, these can go on aviation assets just as well as they could go on space assets or ground assets. So depending on the requirements in the mil standard spec really drive the cost of the modules based on the environment you're using them. So I don't see any of the other questions there, but
just quickly, David, one is what is the TRL level of your tech? And the other question is what type of IB&V testing has been done on this within DoD? Yeah, so TR level sits at right now at the Air Force in the OTA is TR level 6. The modules that you see are kind of a phase 1 prototype, and we'll take them into a phase 2 prototyping effort, hopefully with Hanscom as well. And vulnerability testing, again, the big vulnerability test that we have right now is the Air Force's red team and blue team tests that are wrapping up at Hanscom. So once those reports are out, if they can be shared, we'd love to get them out to multiple agencies within the Navy. Hopefully that's the case. And even hopefully to some aspect share them with some of the companies we want to partner with as well. So, but the big VMV testing going on right now is with the Air Force. So again, I appreciate your time. Would love to talk to many of the companies that were on the line today. And hopefully we've got you thinking a little bit about how using Cs can protect your technologies within the U.S. Navy. Thank you. Yeah. David, thank you so much. I really appreciate it. Again, I will send everyone's information to everyone else so you'll have all that contact information. If you want to type your answers that might be more robust, I'd encourage you to do that. But again, thank you so much for your participation. Next, we have the pleasure of hearing from Aaron Pierce. Aaron is the CEO of Pierce Aerospace. Aaron?
Thank you, Julie. And thank you for everyone taking the time today. So we are focused heavily on remote identification technologies for drones. And what that means is that we're actually going to tell you who's who behind the drone that you see flying around in the sky. So normally I start off this presentation with a story about how we will soon be able to select an airdrop option when we're shopping on Amazon. And that the only reason that airdrop option is available is because we supply some of the identification technology that is handled in the background of that. we don't have a slide for it yet, but most recently we've been engaged with several different companies, entities, both here and outside of the state, to help develop a COVID-19 response via drones, where we're kind of the anchor technology that can help to take drones and put them in the sky to go deliver blood, supplies between hospitals, and even take tests out into the community. We've had additional growing interest with that. IU Health is supporting us in that effort. We've actually got a very large contract manufacturer that's preparing to be able to retool their entire production line to support a mass production of fleets to get this out there. So just kind of on that caveat, if there's anyone on the line interested in learning more about that, we're happy to speak offline and further. But we'll get into it now. Next slide, please. So the biggest news that our company's had at the beginning of the year here is that we were invited to join the FAA in a remote ID cohort. We are in there as a partner to Intel and working with the other partners in the cohort are Amazon, Google, Intel, T-Mobile, Verizon, and Pierce Aerospace here from Indiana. So our focus on that cohort is to actually develop a MVP that we can push out in the operational world by December of this year. Like I mentioned, though, based on some of the things that have been going on, we may be advancing that timeline quite significantly. A big driver behind being able to figure out who's who in the air is safety and security, and that's a driver that the FAA is very concerned about, and that it is very concerned about with some of the other government partners and agencies. And that question has to be solved by remote ID before we can see the commercialization of the drone industry at a large and meaningful scale beyond some of the more localized types of operations that exist today, like surveys and filming. But this problem really I want to really address this from a home perspective as well. Could we do the next slide? So last year at the Indy 500, there was actually a unauthorized drone that flew over the pits during the race, not once, but twice. And the only way that law enforcement were able to track the drone down is because the pilot was stupid enough to actually fly out, swap out batteries, and come back for another flight. And luckily, it was just a drunk in the coke lot, and they were able to find him by physically following the drone back to where he was flying from. But I want to paint that as a picture because it shows the vulnerability gap that exists today. And if that was a criminal or a terrorist, it would have been a single flight, and the implications would have been far more severe. We play a significant role in this whole ecosystem, but especially on the security and the safety side of it. We can take our identity information and feed that into command and control and counter drone systems that can much more accurately determine who's who in the airspace then, so that they can allow those IMPD or state police drones to operate for the security purposes, but make sure that we can keep both malicious drones as well as coke lot wandering drunk drones out of the speedway during the race. But that's what we do on the security side. But again, I want to paint the picture that this technology is dual use and dual hat, and we help to enable the commercial side as well. And next slide. So that we can do wonderful things like airdropping Chunky Monkey or whatever your favorite preferred good is that you just must have right now. So we've been engaged on the commercial side pretty heavily as well, and have some partners on that end. And really, we're going to see this industry take off, pun slightly intended, as we see consumers start to use this for the first time and see, when they can get that good, that highly desirable good airdropped to them, they're going to be bought in on this. Whether that be something much more practical, or something that's maybe more of a little bit of a luxury lust, like having airdropped Chunky Monkey on call. Next slide. So there's really three pillars to the unmanned aircraft industry. They are remote ID, unmanned traffic management, and counter drone technologies. And we as the remote ID providers help to deliver that information to both the unmanned traffic management and the counter drone technologies. And once we get all three of these pillars stood up, that's when we can see this entire UAS ecosystem really take off, and we can start to see high levels of commercialized utility, as well as some of the other more advanced types of things that are actively under development and in testing right now, such as the urban air taxis. And so this is the picture that we're trying to paint and work with our both government and industry partners as we continue in the development of remote ID. Next slide. So we're designed to be very agnostic and plug into existing and future command and control systems, unmanned traffic management systems, individual counter drone systems. And we've actually done this already. And so as an example of how the product flows, back in November, we integrated with a Northrop Grumman and LightEye counter UAS system that was hooked into a Stryker, US Army vehicle, out at a US Army Futures Command exercise. And in that exercise, the systems and the sensors that were on board the Stryker were able to detect multiple aircraft in the sky. The operator then made a call into our system to ask, who is this? We were able to then provide the positive ID that they needed to obtain clearance to fire in their kill chain. And we were able to give them that, this is friendly, this is foe type of authorization, which they then used to engage the hostile aircraft with the 30mm chain gun that they had, which was as awesome as it sounds. Alternatively though, just to show an example of how flexible we've designed this, if any one of us on this line sees a drone from our backyard, we can make we can whip out our phone, make a call into a variety of different apps that are out in the marketplace today that we're beginning to work with, and get a notification of whether that's the aircraft that we actually had ordered to bring us our airdropped Chunky Monkey, or if it's not, use it to, if it's being malicious or we have a concern about it, use it to make a report to law enforcement. And kind of at a big picture, at a high level description, we're really providing a license plate and BMV system for the sky with this product. Next slide. So traction to date, we have multiple MOUs from both the Air Force and the Army. We would very much like to engage more closely with the Navy, especially with some of the crane folks here at home. I mentioned the Northrop Grumman example earlier. We are also working with Booz Allen Hamilton on an integrated air defense technology, and we're working with multiple unmanned traffic management systems, including UAS Sidekick, who's focused on public safety, as well as Altitude Angel. Altitude Angel is the largest UTM provider for Europe, and we're working pretty closely with them on some of the remote ID pieces for Europe as well. So next slide. So we have been engaged with AFWERX pretty closely, and won a phase 1 with them to do some of our work. And I know AFWERX has been mentioned by a couple of the companies on the call today. I know they work very closely with NavalX as well, but just to give awareness, I worked with Techstars pretty closely with some of those folks. And I always want to make sure that everyone's aware that of the matching programs that they have through their SBIR program. We are eligible for that as well through our work in phase 1 award with them. But I want to make sure that those are things that the rest of the people on the line are aware of, and I'm happy to talk about that process as someone who's gone through that if anyone's interested. Next slide. So from a team perspective, I mentioned I came from Techstars. I was an entrepreneur in residence with the first ever US Air Force Accelerator program. I'm also a Mitch Daniels Leadership Fellow. Our CTO, his name's Gary Bullock. He used to be down at Crane, worked a couple different chair positions, and is heavily engaged in unmanned systems as well as software and modeling and simulation through his distinguished career with the Navy. Advisor-wise, we've also got the gentleman who invented drone forensics advising us, as well as former executive levels, including at Motorola. And for the local crowd, we've got wonderful guidance always from John Wexler. Next slide. So again, just want to make sure that we can get our name out there, and we're very open to work with Indiana companies as we progress forward on this, especially as we're looking at this COVID type of response. We've been told to get our slide decks and our team ready in case we are called upon. So if there are folks on the line that are interested in that, very happy to explore. And again, from a big picture perspective, we fulfill that remote ID pillar that's needed to bring this entire ecosystem to fruition, so that we can both have the security that fuels the commercialization potential, and very much focused on a dual use perspective for providing remote ID to both defense as well as commercial application. And happy to take questions.
Thanks so much, Aaron. I don't see any yet. It could be that they'll come later. Again, if they do, I'll make sure that they are connected directly to you. And I've mentioned numerous times this afternoon and this morning, shortly after our meeting concludes, I'll make sure that everyone who's participated has each other's contact information. So thank you so much for your time. Great information to share. And I'm sure you'll be hearing from several others in the not too distant future. So next we have Bradford Thorne. He's a senior R&D engineer with IF Battery. Bradford, are you on the phone with us?
I am. Can you hear me all right?
Yes, we can. Thank you.
Awesome. So I also have Michael Zekin here as well, one of the other engineers. And so originally we were going to be talking about our flow battery chemistry, but in light of COVID, we've actually changed perspectives as and picked up some extra projects as a group here. And so we've been focusing on over the last 2 weeks on a resuscitation device or a ventilator. We had been tracking, as I think many people had, the situation in Italy and kind of the dichotomy that we were seeing between there and South Korea, as we saw the lack of provisions or the lack of ventilators that had an enormous effect on the case fatality rate within Italy. And unfortunately, as we were seeing that progression, we were realizing that the United States was very much more on the side of Italy in that progression. And if we could go to the first slide, that'd be fantastic. In that, we have been seeing, as everybody knows, is a similar progression within New York. And so we wanted to create a mechanical ventilator. As you've likely seen many articles come up over the last week or so about providing mechanical ventilation with circulating around a ambu or an ambulatory bag. Actually, if we could also go to the next slide, that'd be fantastic. And so we, that in of itself is an excellent thing, having the ability to provide respiration or ventilation for a patient that can't breathe on their own, but it's only part of the story and only part of the need. One of the very important things with the disease state within COVID and the progression into ARDS or acute respiratory distress syndrome is the necessity to have very fine control over the provision of with the clinician having control over the oxygen and breath control of a patient, especially as we progress further into the disease state. And so our goal with this over the last 2 weeks, which we've been making progress on, is to have a sensor mechanical actuation for ventilation, but that is paired with a sensor suite that allows us to provide about 90 to 95% of the capabilities of a full ventilator that would otherwise be about $25,000 to $50,000 within at a price tag of around $1,000 to $1,500. And the very important part of that is the ability for these overstressed systems to set and dictate ventilation prescriptions for these critical patients and not have to provide deep supervision and pull additional hospital resources away from them. And so, yes.
Yeah, so one of the, this is Michael, so one of the advantages that we think our system has is ventilators, you know, they basically push air into the patient's lungs through a few processes, but one of the advantages of our ventilator is that all the ambu bag, the tubing, all of that is already sterile packed, FDA approved, and we're basically going to be modulating that. We're not touching anything inside of that, and hopefully when we submit to the FDA a little bit later, that's going to avoid some problems on our end. We also, one of the advantages we have over these other, pretty much every other one of these mechanical ventilators that have been coming out, is that we have flow sensors, pressure sensors, and oxygen sensors within our device, both right near the patient's mouth, as well as coming right out of our bag. And that gives us some feedback control, which then drives our motor functionality. So instead of these other devices, which are more of a set and forget type deal, ours has a feedback loop to ensure that the patient is getting the proper amount of air, proper amount of oxygen at the right pressures and rates that the clinician sets. The ambu bag and tubing themselves, about 300,000 of those units are in the US supply chain per month, and we hope to tap into some of that. And we're gonna probably skip through the next 2 slides of market validation and market size, because those are pretty laid out. And we could just get into what would be our 7th slide, initial proof of concept.
So I'm not sure if there's a video that can play here, if it can be clicked, but this is just a early stage demonstration. We haven't had much time to update these slides in the last few days, but we've done 3 or so iterations since this point. And we're currently in a late stage prototype, moving into first article testing a little bit later in the week, with the hope to move into animal trials early next week. And so we're progressing quickly through this, and that is largely in thanks to that sensor system and the full suite integration there. And so as you can see here, there is a very simple compression device that allows that we know true position of, and so we can consistently give true tidal volumes and monitor that through several different modalities within the system. There's also currently this prototype is discrete, but there will be a user interface that is very similar to the existing interfaces that are supplied with conventional higher end devices. And so, and the user interface workflow, all those things have been modeled after the existing devices with similar alarms. So the alarm system, as the FDA requires, tracks very, very closely to existing systems so that the level of retraining is minimal when moving over to a new system.
Yes, we'll kind of, if you could go on our next slide here after initial proof of concept. Perfect. So here's a little bit of an overview of our hardware. So we're trying to design this with the ability for mass production, and with the existing supply chain, albeit somewhat modified supply chain in mind. So a lot of just kind of going over, oxygen is going in two directions, from two areas by the O2 source. There's one that's coming from the bottle, the wall, whatever the pure oxygen source is, as well as from some of the ambient air in the room. That again goes into this ambu bag, which is shown in this blue purple, and that is compressed via the compression strap, which is essentially tied to our drivetrain, which is then tied to our motor. That motor is controlled by a microcontroller, which is integrated with a feedback loop. Drivers of this feedback loop involve clinician input, pressure, airflow, as well as oxygen content. Basically, when the clinician sets some of the parameters via that UI, then this microcontroller takes all of those sensor inputs and then determines how fast, how slow, etc., to drive the motor in order to get the right pressure, airflow waveforms, as well as a few other parameters that we could, not on this call, but we'll feel free to discuss later. If we move on to the next slide, well, I'll let Bradford talk about this one. This is his jam.
So these are some of the key performance indicators that we look at when evaluating devices or ventilators. One of the main classifications is the mode system. And this is very important for the way that we're treating these patients. A lot of ventilators, so ventilation, the primary mechanism by which it's done is it often is done in an assist control capacity where somebody is moderate to lightly sedated and they can then breathe on their own, but there is an assist. So there's a breath detection, which is very important. And so we've added this to our sensor suite to allow for detection of when the patient is breathing. And then we're just going to assist them. We're just going to provide a little bit of extra compression to help the air into their lungs. As we progress further into this disease state for ARDS and COVID, PEEP or peak and expiratory pressure is a very important way and mechanism by which we can increase the blood oxygen concentration in these patients by keeping the pressure in the flow circuit always above ambient pressure. And so this is very widely used in the clinical presentations and can be difficult with other systems to achieve that are on the lower end of costs. And so in the metrics for tidal volume, breath rate, and pressure, we've outlined cases that will, or parameters that we've hit here that allow us to treat around 95% of the patients. What we want to do is we want to be able to treat the vast majority of those patients who come in and reserve any of the much more complicated patients for the existing ventilator systems.
And then if we could go on to the next slide. So here is our development schedule. This is kind of always a moving target. So we very recently, I think about 48 hours ago or 24 hours ago, we received a grant from the IU Health, Indiana University Health, in order to really start accelerating this timeline. So, you know, Bradford was mentioning we started this project a little over 2 weeks ago. Went to proof of concept prototyping. Today we cut out some, or yesterday, and then today we're finishing up dropping some POs for our, you know, initial advanced prototype testing is what we're calling it. When those come in tomorrow, fully assembled, we'll start some testing. We'll go to our first article POs, which the FDA likes to have highly representative hardware of your final design. We're actively working with regulatory specialists in order to craft our 510(k) submission to the FDA. And then hopefully next week, if everything goes well and we stay on this path, which we have been so far, we will start some animal trials. And if we go on to the next slide. On our business model, so we have a few patent applications, but I'll spare the details on those. But what we're actively doing is we're trying to seek a licensing partner from a major manufacturer in order to essentially help us submit this 510(k). Being a battery company until about 2.5 weeks ago, we don't have an FDA quality system in place, which is very important. in the FDA's eyes, and as it should be. In order to set that up, that would take longer than this, than we have time right now, frankly. So we are trying to find right manufacturing partners. If any of you guys on the call think that you would have some, please feel free to pass on our information. We're actively crafting this FDA submission right now with our regulatory specialists. And I think our one of our business guys wants us to say that we will entertain either exclusive or non-exclusive licenses with usual business terms, etc. So that's kind of the rundown of this ventilator project, when we would like to really thank IU Health for their $75,000 grants in order to really expedite us.
It's great, Bradford. Thank you and your team. It's a great presentation, very informative, and I have a feeling you'll be hearing from a lot of our partners here. You have kind of the perfect solution at the perfect time, so thank you. Next, we have Martin Swaney. Martin is the Chair of Intelligent Systems Engineering at Indiana University. So Martin, please. Oh, and I see Adam's name on there too. I'm sorry, Adam.
Yes, so can you hear me?
Yes.
Okay, hi, yes. And I'm a professor in Intelligent Systems Engineering and the chair, and Adam is works as a Crane employee who's pursuing his PhD in the Intelligent Systems Engineering program under the Crane PhD Fellowship, and he's a DoD Smart Scholar as well. So I'll kick it off, and then he can talk about some of his recent work. So next slide, please. So we are, just as we call ourselves the Open Group, that's Open Programmable Networks. And we focus on a number of technologies and approaches to make networks more scalable, more efficient, including software-defined networking, network programming, network performance management and adaptation, acceleration. As you'll see, we do some network acceleration using FPGAs, and we've worked recently on some mobile ad hoc network projects. We have a NIST-funded project called Wildfire DLN that is designed to support wildland firefighters who have no persistent communication infrastructure or and basically to act as data relays, data ferries, getting them up to date remote sensing data. We've also done some work in FPGA security, and I guess not mentioned here is high performance computing, where we again focus on the optimizing network performance, because that's one of the key drivers in being able to do efficient parallel computing. So next slide, please. We've been thinking, like a lot of folks have been thinking, about networks at the edge, and they're very different than than the network core. The network core is mostly stable, mostly fixed. There are all kinds of transient things that go on, but over time, it is its availability is startling, especially given the increased utilization that it has been undergoing in the last couple of weeks. And so it's clearly robust and mostly unchanging. It changes on the order of weeks, not hours. At the edge, we have technologies like IoT, connected everything's, mobile ad hoc networks and vehicle ad hoc networks. They have very different constraints, bandwidth limited and energy limited, also unreliable, and in many cases, and so also very dynamically changing. So a lot of work goes on in thinking about either or, and our work of late has been to think about combining and having these work together seamlessly. So I'm actually working on an NSF proposal right now to take the quality of services that you see in a radio area network, map them into software-defined network configuration support in the core of the network, so to allow us to make end-to-end guarantees of the sort that you can only make locally in general. Next slide, please. So we have the inarguably cleverly titled project that actually also happens to describe what we do. So it's not even terribly tortured in terms of its acronym. But we think of our overall ecosystem as in-network distributed infrastructure for advanced network applications. And there are more components of it than this, but I just want to highlight a couple of things. On the left side, this is a really busy description of what we call an in-locus compute node. And this is our in-network or edge processing edge execution model. A lot of people, especially in, I'd say, academia and in industry, think of the edge cloud as being small Linux machines running Docker containers or something. So they are edgy by just virtue of being slightly scaled down and put toward the edge of the network. At the other end of the spectrum, there are implementations in ASICs and FPGAs that, and DSPs that are doing very specific sort of data processing that takes time to implement and then is not so malleable. So in-locus is targeting something in the middle, which is a stream-oriented network processor that is deployable on microcontrollers, microprocessors, FPGAs, and network-oriented processors. And it works a lot like cloud stream technologies like Twitter Heron, where they're processing streams of data at incredible volumes. But it's designed to run in a very constrained environment and be very sensitive to resource usage. So there are a limited number of functions. You can load them in operations that are essentially consuming packet of data and one or more packets of data, producing one or more packets, but they are very network centric. So we use SDN to steer particular data streams toward the appropriate compute element where we've loaded the appropriate in-locus module, and they can be very efficient, low latency, and extremely high data rates on a very simple device. On the right-hand side is a picture describing Flange, which is our flow-oriented programming language. So we think of considering data going from sources through processing steps, arriving at some sink as being in terms of network flows, in terms of flow graphs. And so Flange is a language to describe our desired outcome flow graph. It discovers the topology of the network. It maintains that as an input graph in something called the Uniform Network Information Service, UNIS. It's making dynamic measurements to determine available bandwidth. We have the Flange language describes the outcome. The compiler generates modifications to the graph that are ultimately result in routing changes in the software-defined network. So again, like I said, we're using the stuff on the right to send appropriate flows of data to processing elements, arrays of processing elements on the left. Next slide, please. So we do a lot of talking and about this thing, and it turns out that in conjunction with the 5G telecommunications standards, there's a growing group of standards for what's called MEC, or mobile edge computing. I think it might be also have been, I think it might be backronymed into multi-subscriber edge cloud. But it's basically it's the idea that there are a lot of applications that are latency sensitive and need local compute resources going all the way to a large cloud data center many, many milliseconds away is not appropriate. So essentially a lot of the stuff that we've been talking about before, it could be summarized now as we're looking at a MEC architecture. So with that, I will turn it over to Adam.
Thanks, Martin.
Thank you.
Can everyone hear me okay?
I can.
Yes, yes.
Okay, good. Sorry. All right, so along with what Martin was saying, just looking at one particular use case on this mobile edge computing architecture is augmented reality. So I'm sure people have seen augmented reality, like Pokemon Go is probably one of the most famous ones. But those are very simple uses of augmented reality. As we get into more advanced capabilities that, in theory, 5G networks will enable us, we're going to get into a more higher accuracy, higher resolution capabilities, particularly with stereoscopic augmented reality and being able to do accurate depth maps. And what I've done here is just kind of do a little bit of quick back of the envelope calculations to kind of motivate the example of what we're trying to say. So in augmented reality, to produce a depth map, you basically need 2 images separated apart, a lot of sensors, I mean, separated about as far apart as your eyes. So there's just the same way that we interpret a depth, computers are doing that same kind of thing. So they take 2 images, and if those images are both at a 4K resolution and an uncompressed format, you could be talking about as much as 12 gigabits per second or 24 gigabits per second for 2 images being streamed. And then to do depth mapping, it's a process of comparing 1 pixel to several neighboring pixels, all very rapidly, to understand how far apart things are. So essentially, you could be looking at something on the order of 1.2 teraflops, which is a trillion floating point operations per second. And to kind of give you some idea of how powerful that is, an iPhone 11 can do roughly 1 gigaflops, whereas a PS4 Pro does about 4.2. So as we look at mobile edge computing and 5G capabilities, we're trying to do these kind of technologies that are requiring as many as 1.2 teraflops of calculation on, through someone's cell phone. So certainly technology that's not quite there yet. So the mobile edge compute use case essentially offloads that data to edge nodes. Then those edge nodes then share in that computational resource sharing to make those calculations and then send that feedback as quickly as possible. But if you can imagine in an augmented reality scenario, that's happening in real time and with very minimal delay tolerance. So those applications have to happen very, very quickly. And one of the things that hasn't been solved in mobile edge computing yet is how are those decisions made to actually, what data goes where, into which edge node, how is the complexity or the computation shared across edge nodes, those microsecond routing decisions haven't been quite worked through. So that is our kind of our civilian side use case for intelligent routing. And if we can go to the next slide, I have a use case using what's called the Internet of Battlefield Things, and maybe a lot of the people listening in can relate to this a little bit more. But the Internet of Battlefield Things is an Army design concept of where everything is essentially connected. So you have all these small devices that are connected over a network. Navy has things like the Fleet Tactical Grid where all their systems are connected. But the bottom line between these systems is, one, these networks are completely self-contained. So there's no network core necessarily that they can reliably reach back to. They're bandwidth limited, just like Martin was saying earlier, that networks in our current systems are measured in hundreds of kilobits to at most tens of megabits per second. And they're very small devices, so they have limited energy storage and compute capacity. But we're trying to push them to do things like full motion video, target classification, intelligent sensing, do all this computation on the fly as it's happening. So those devices are being networked together to rely on them to perform these calculations, which is really going to stress the capability of their compute capacity and their ability to send network data through these constrained pipes. So the question here is, how do we use these small devices to efficiently route data while managing the energy storage capability and the computational capacity of these systems. So that brings us to our next slide. So what we've started looking at is what we call multi-objective routing optimization. So everyone is somewhat familiar with packet routed decisions. I mean, the internet revolves around routing of packets. Those algorithms are fairly fixed, like Martin was saying, going through the network core that's pretty stable. There's some very common algorithms that are used. They've been used for going on 60 years. They were invented even before the internet was developed. Many people probably heard of Dijkstra's algorithm or Bellman-Ford or Ford-Fulkerson, very well-known algorithms. But they essentially revolve around trying to find the shortest path. And that shortest path is usually defined, quite often it's defined by bandwidth. How much bandwidth can we have? How quickly can we send a piece of information from one node to the next node? But they can be also determined by geographic distance or maybe network delay if you're talking about real-time communications like we're doing over Zoom. But the limiting factor of these algorithms is that they focus on one objective, whatever that shortest path is and how that's defined. Our problem is now we're looking at routing information both as quickly as possible, but then also trying to manage the energy capacity of constrained devices and trying to understand how we can distribute computational capacity within the network. And we could list a whole host of other different ones, like maybe there's a certain functionality that exists at a certain node that doesn't exist at other nodes. So we have to figure out how do we route through all those. So essentially we have this multi-objective routing problem that standard routing algorithms aren't able to figure out. So next slide, please. So we've started looking at what we call multi-dimensional routing. And from a very basic perspective, we treat each objective as a separate dimension in a network. So essentially, if you have a network map of a particular a route that you want to send data down, we increase the size of that network to represent each dimension or each attribute that we want to optimize for. And we're able to actually solve that using some very basic linear programming concepts. We found that these routing capabilities are fairly tractable. They're really good for, it can be done in small devices. We've got a hardware network set up in one of our labs at IU that we can run on several nodes and calculate this routing scheme in microseconds, which is of no significant delay when we're talking about the kind of a data throughput we're trying to deal with. And we can really, we really get a optimal solution. So this routing concept is working well for us, but we're starting to see as these networks get larger and they get more complex and even more objectives, say, hundreds, if not even thousands of different objectives, this linear program problem, because it's in a complexity of big O notation of n to the 3, where n is the number of nodes, it does become quite large. So our next big research trajectory is on the next slide, is looking at policy-based routing using reinforcement learning. So essentially, reinforcement learning is a goal-directed machine learning approach. The idea is to train an agent to learn what's the optimal behavior using trial and error perspective. The nice thing about this machine learning approach that is it generates its own training data, so we don't have to iterate through thousands of different routing scenarios and then feed that into an algorithm so that it can learn from that. It can actually learn as it goes. So it starts off maybe not very particular optimal, but then it optimizes as it goes through several runs. So we route these, or we provide this agent routing objectives expressed as rewards, and those rewards are somewhat mutable. They could be, focus on getting it there, getting information there the fastest, but also expanding the network compute capacity, or get it there quickly and avoid energy-starved nodes. So we can provide very complex routing objectives, express those at different levels of rewards. And the advantage of this is that the network complexity can actually grow quite large. So, hundreds, thousands, and hopefully even tens of thousands of nodes. and the cost of performing these routing decisions doesn't increase very dramatically. And as we train these agents, they can be easily adapted to larger networks without having to restart the training process. So there's a lot of advantages to this approach, and we're just starting to get into it. But that's our big focus right now. The challenges that we have are reward tuning. That's probably going to be one of our bigger challenges, trying to figure out how do we really incentivize the right kind of behavior that we want. The training time, how long does it take to actually train these algorithms to work? And then the computational complexity. And this is probably the biggest one, that with our linear programming approach, we proved that even small edge devices can perform this kind of calculation. But we haven't quite wrapped around how quickly can we do this reinforcement techniques on small devices and still get optimal routing decisions in a measurable amount of time. If it takes us 2 minutes to determine a routing decision, that's probably obviously too long for most data. But if we can do it in milliseconds and microseconds, that's the approach we're trying to take. So this is our current approach right now on doing machine learning based routing decisions. And if you go to the last slide, the future work that we want to look at is actually deep reinforcement learning for multi-objective routing. So now we're starting to talk about, hundreds of thousands of nodes with, hundreds or thousands of different attributes. The advantage of deep reinforcement learning is that it combines the learning capabilities of deep neural networks and reinforcement learning. And so we can better approximate the state action space and actually get more finer tuned rewards through training of a neural network, and actually get some more advantages that we didn't see in even the reinforcement learning approach. The disadvantages obviously is that that requires more complex data, a larger range of data, more data. But as we've seen in recent advances in groups like AlphaGo and AlphaStar that they've done, if you haven't seen some of that research, it's really fascinating. They've done a lot of work with very complex games and trying to optimize how a reinforcement learning agent can actually learn to play games. We see these routing problems as essentially the same kind of a problem, and somewhat less complex than a complicated game like StarCraft, if anyone's familiar with that. So we believe this is feasible. The big challenge here is going to be getting the right amount of data to train it, and then also being able to train a network in a reasonable amount of time to be able to make these routing decisions in real time. So that's where the trajectory of our focus will be in the near future. So with that, I think that's my last slide.
Great, thank you so much, Martin and Adam. Very much appreciate your participation. I'm sure you'll hear from many others that are currently on this presentation webinar. So again, thanks so much for being part of what I think is a pretty terrific day. Next we have Tom Budd. Tom, I love your title, Solutions Manager. He's with Manufacturing Technology, Inc. In fact, Ann Fields and I met him just a few weeks ago when we made a trip up north. So Tom, welcome, you have the floor.
Thanks, Julie. Can you hear me okay?
Yes.
Great. Hey, I did want to send out a quick but sincere thank you to both you and Ann for making it up, and Dave Tamelis from Third Coast Federal for making that trip to set up and host the Tech Bridge discussion. That's we appreciate your efforts, and that's a great opportunity that it presents. I also wanted to say thank you to everybody online for listening. Man, I'm impressed with what we've got in Indiana. It's super exciting and very encouraging. Next slide, please. So my name is Tom Budd. I am the Solutions Manager for Friction Welding for MTI, and as my title kind of implies, I help customers navigate their projects from research and development or ideas all the way through to completely integrated equipment systems and anything in between those two across all of our technologies. I'm here today, next slide please. So I'm here today to give you a glimpse about our low force friction welding technology development that we have going on. And if you could go to slide 4, please. So what I'd like to do is just tell you a little bit about who we are, and then just talk about explain who we are as a company, define the friction welding in general so you have an idea of what we're doing and what that means, and then just get into the details on our friction welding development. Next slide, please. So MTI is recognized as a global leader in friction welding. We've got machines in 26 countries, and we currently have over 350 patents relating to the technology. We are a 4th generation family-owned company. They're going on the 5th. There's people in high school and college that are doing internships during the summer of the owners. So and we've been around for 93 years. We're old as dirt. We're a global organization. We're headquartered in South Bend in the US, and we've got 2 locations in the UK and Slovakia, of all places. Next slide, please. Some quick facts. That's our revenue. Roughly, it bounces around 41 million. We have 185 global employees. And then of that, the 230,000 square feet, about just under 200,000 of that is in South Bend at 2 locations that are approximately 2 miles apart. And we have a manufacturing services division, and then the corporate headquarters and the place where we build the equipment. Next slide, please. So we are a global supplier. We've got over 1,000 friction welding machines installed on 6 continents. Next slide, please. And you can see by the list of names here, we span pretty much all industries. We're in aerospace, automotive, agriculture, defense, military, etc. There really isn't a market segment that we have not been involved in all the years. We've friction welded everything from golf clubs to critical aerospace components. Next slide, please. So we do consider ourselves a full service solutions provider. We're the only company globally that provides all the different forms of friction welding solutions, which include rotary, linear, friction stir, and our new latest low force technology. So we basically provide a stepping stone approach from R&D through prototypes, through production to full cell integrated equipment into their production line with robotic load and unload and in-feed conveyance, etc., as required. And then we support that with a global sales and service force. Next slide, please. So what is friction welding? So basically, it's kind of like it sounds. It's imparting a relative motion under load to create friction. So we do that with either a rotary or a linear rotation. In this case, it's similar to the heat that's created when you rub your hands together. We frictionally heat the weld interface of the 2 materials that we're joining to a forging temperature, and then we apply a large load of forge or a force to force those pieces together. Next slide, please. So we do offer all those different technologies that I talked about, but we're just going to concentrate on the linear, which is a reciprocating motion, and the rotational for our new low force technology. Next slide, please. So in a rotary movement, MTI offers the widest range of inertia and direct drive friction welders available in the world today. We've built the largest. And by range, I'm referring to both from a physical size and then just the forge force capability or pressure that's required to perform the process. In the bottom left photo is our Model 40. It's a tabletop model that we used in Manufacturing Day presentation. That same model is just sitting on the bed in the photo of the right of one of our larger friction welders to give you an idea as far as size. Next slide, please. We've also produced the world's largest inertia welder. These are used to produce jet engine compression rings, shown at the top of the page. There's 6 precious metal welded rings that form a compressor ring that's used in a jet engine. Next slide, please. We also have produced the world's largest linear friction welding machines and have production machines in customer facilities producing bladed discs for military and commercial jet engines. Linear friction welding uses an oscillation motion, which is back and forth. If you look at that example in the upper right-hand corner, each one of those near net shaped fan blades is forged, and then each one is individually welded in a back and forth motion to that hub in about 10 seconds, and it's welded to a final position within 0.02 of an inch. Next slide, please. Oh, and on the blisk, that typically after they're welded, there's a process where we need to machine that material at that weld interface, which I'll get into later. Next slide, please. So if just some general friction welding examples, the Apache helicopter uses the rotor shaft we weld for North Star or Boeing. The 747 uses the drag brace we weld for Noranco or UTOS or Boeing. The F-35B jet uses the lift fan gears we weld for Aerogear. This gear provides the engine for vertical takeoff and landing. It allows it to pivot. And then we also weld the fuel injector posts for the Aerojet Rocketdyne RS-25 engines that were previously used on the space shuttles and now on the new SLS launch vehicle for NASA. There's about 600 welds per engine that we weld actually here in South Bend. And then we also perform a number of critical dissimilar material interface welds for a number of people in aerospace sector, private companies and public, and we're not allowed to name those by our contract. Next line, please. So I won't go through all of these applications, obviously, but this is just to give you an idea of some of the applications that we can share. The critical takeaway here is the use of near net shaped parts as a form of additive manufacturing. These are used to create unique assemblies that are stronger, faster to make, and more cost effective than traditional methods. So in the example there, we can join a tube to a disc and eliminate machining all of that from a solid piece of material. We can also join dissimilar metals, perhaps joining one piece that withstands a great deal of heat to another piece that wears a little bit better and bears mechanical strengths a little bit differently. Next slide, please. And I'll just make everyone aware, this is a part example interface on our website. You can quickly go there and just select part examples and ideas by geometries, materials, industrial applications, or technologies, and it'll bring up an image of different parts that we've welded and the technologies behind it. It's a great resource. Or you can just contact me if you're lazy or want to get through it quicker. Next slide, please. And so let's talk about low force friction welding. You can skip ahead to the next slide and the next one. So we are the only company in the world that has introduced low force friction welding. So what is it? We basically use an external energy source to raise that interface temperature of the parts we're getting ready to weld. So that's in addition to the friction welding heat that's generated at the weld interface. Next slide, please. So when looking at a solid state welding, we describe it as a continuum. On the far left, you have the old diffusion bonding. It uses no motion whatsoever. It uses a lot of preheat and a bit of force, but it takes a long time. And if you have hundreds of parts to make, you need to accelerate that process, which kind of leads us to the far right, friction welding. We use zero preheat in the traditional friction welding sense, and we use 100% relative motion to generate the heat, and then we use a forge force to bring them together. So this new technology, low force, lies in the middle of these, or somewhere in between the two technologies, depending on your materials and your application. So we're applying preheat, motion, and the forge force. Next slide, please. So there are two distinct proprietary low force development technologies designated here as T1 and T2, and either can be used, or we can use either with our traditional friction welding machine motions, either a linear or a rotary, but they require NDAs for detailed discussions. But so I've kind of created this to lay it out and where we're at with each of the technologies. We do have two low force lab machines installed at MTI. One is a rotary technology and one is in a linear. On the linear side, there are over 12 rotary T1 technology machines installed in customer production cells globally, producing critical auto engine parts. We're calling the T1 technology in a rotary configuration as a TRL level 6, since it's joining traditional steels. This is actually a piston application. So you could almost argue that it is at a TRL 9, since it's producing millions of engine parts globally over the last few years. The low force technology T2 on the linear machine on the left is currently under development and was just recently used for an SBIR DoD Air Force project. Just completed, turned in the final report on March 10th, a little bit ago. Next slide, please. So let's just go through some of the advantages. Next slide. Advantage number 1, it is a solid state joining process. Friction welding is a solid state process, which means joining occurs below the melting temperature of the two parts being joined. We don't change the base material properties as is done with fusion processes that can melt the material. Since there's no melting, there's no solidification defects that occur, there's no gas porosity, segregation, or slag inclusions in the weld interface typically. The resultant joint is of a forged quality joint. So as a result, the weld properties of a low force weld are superior to those created with the fusion processes that you see on the right. Next slide, please. Advantage number 2 is what we refer to as smooth flash. So during friction welding, as the two parts are heated and the material at the weld interface softens, and that excess material that starts to extrude away from the weld interface, that's referred to as flash, and you can see it highlighted in the detailed items there in all 4 photos. That flash is coherent, it won't flake off, and can often be left intact if the design allows for that. But the low force process smooths that flash geometry to reduce machining part cycle time, or may even entirely eliminate that whole flash removal process and the associated costs of the equipment footprint, and the related equipment energy, maintenance, operator, etc. Next slide, please. Advantage number 3 is what we refer to as low upset. We refer to upset as the lateral force that's used to plastically displace and fuse the materials in a weld, friction weld. We can dial in the application for a smooth bulge, as you see on the right, to virtually no flash that you see on the left, that might be used with a tube application where we can't get inside the tube or inside a geometry to machine that flash off. Next slide, please. Advantage 4 is simply cycle time. Cycle time is faster. The actual part-to-part cycle time of the piston application that I referred to was reduced by over 32%. So you can imagine if you're producing millions of parts, or even if you're producing 200 parts, that's a considerable savings in time and production dollars. Next slide, please. Advantage 5 is reduced machine size. With the lower process forces that are required to make a solid state weld, the size of the machine decreases, freeing up valuable space on the production floor. And this in turn reduces the machine base, the frame, and all the costs of the materials and the machine that are designed into the machine to counteract those forces. In the automotive case, that was a reduction of 90% of forge force. Next slide, please. Another huge advantage is a larger range of part capacity. Low force friction welding can accommodate a wider range of parts. Instead of having a small, medium, and large machine, we can use a single machine to cover the range of the 3 traditional machines as shown there. So you've got a smaller footprint and a larger range of parts. Next slide, please. Advantage 6 is post-weld heat treatment. If materials require tempering to improve their hardness, post-weld heat treatment can be accomplished in the low force friction welder. There's no additional machines or steps that are required. So we're already using that technology for the preheat. So now we're going to take advantage of it in the post-heat process as well. So in a traditional footprint, we can accomplish multiple processes. Again, both a time and a cost saver. Next slide, please. So I'll just briefly show you, next slide, some of the materials and geometries. This isn't a comprehensive list, and they're kind of set up by machine motions. The linear machine technology T1 has been concentrated on coupon sizes primarily on the bottom. The rotary machine technology has been developed using a larger number of geometries, and we've run customer prototypes, and we're actually running limited run production on various parts on the top. And then finally, I did just, the next slide, please. I did just include some of our quality certifications for reference. And then next slide. If anyone is interested, this is an open invitation to anyone. This week of Thursday, we are having a live webinar with our CTO and CEO on the solid state friction welding benefits. And if you want to shoot me an email, I can get you hooked up and have you join. But that's pretty much it. I want to thank everybody again for their time, and I look forward to meeting everybody in person at some point in the future.
Everybody's hoping that, Tom. Thank you so much. That was terrific. Again, thank you for your participation, and we'll be back in touch with you.
Thanks,
last
Julie.
but not least is Chuck Smith, Pete Grossman, and Tom V. Tom, I hope I haven't butchered your name. Even though they are last, they are, again, certainly not least. I hope all of you will still hang on. Their presentation is certainly worth listening and learning about. So with that, Chuck, I'll turn it over to you.
Okay, thanks. Hopefully you can hear me. I'm going to turn it over to Pete. He's going to be, he's the technical guy. He'll be going through the next set of charts.
Okay,
so Pete,
thank you. We can hear you.
All right, thanks, Chuck. All right, this is Pete Grossman. I'm the Advanced Development Manager at Systems Engineering Group. So if we go to the next slide, I'll just dive right in here. So who is SEG? We're a wholly owned subsidiary of Telephonics Corporation, but we've been doing the work that we do for longer than we've been owned by Telephonics. We're about 160 staff, a lot with advanced degrees, masters and PhDs. We have a secure facility. We largely do classified work supporting the DoD, primarily the Missile Defense Agency and the U.S. Navy currently. 85% of what we do is modeling and simulation and analysis. We don't really do much of any manufacturing. It's mostly the computer-based technical work, although we do also have a significant component of what we do, about 15%, is sort of on-site support, government services type contract. We have quite a few senior people on staff who are former program managers, technical directors, et cetera, from various DoD government programs like Aegis, CMD, Navy, PEO, IWS, and other areas like that. Chuck, who talked right before I did, is one of those people. He's the former program manager not program manager, Cheng for the SN3 program. So we've been doing what we do for about 25 years now, and what we do is threat modeling for the Missile Defense Agency and the Navy. And when I say threat modeling, what I mean is primarily ballistic and cruise missiles. How do they fly? What do they look like to radars and other types of sensors? What's coming next? And what could they do that that the intel community hasn't seen them do yet? And that involves a lot of what we do is high fidelity physics-based modeling. That's sort of our bread and butter. That's what sets us apart from other people who do threat modeling, who may not be getting into the from first principles physics-based high fidelity modeling as much. We're focused on that piece of it. We provide a lot of the GFI content that goes into the various missile defense programs, especially on the requirements feasibility analysis, the weapon system design side of the systems engineering V, if you're familiar. So a lot of our data and modeling gets used by prime contractors and the DoD program offices for mission planning and weapon system design. And then down at the bottom, you can just see sort of what the mix of our different types of expertise are: aerospace engineering, electrical engineering, mechanical engineering, computer science, physics, math, and a pretty good mix of different education levels, largely PhD and master's. Next slide. So getting into a little bit more detail on what is threat engineering and what do we actually do. A lot of what we do, we get information in from the intel community, and what that means is assessments that they're doing on things that they've seen or gotten wind of happening. And why you need someone like SEG to do work beyond that is that the intel community's job in general is not to go out on a limb and say what could be, what do we think we might need to be worried about, or where is this going in 2, 5, 10, 20 years. They're looking at what do we know for sure, what have we seen, and what have we heard. So they tend to, what comes out of the intel community is very useful, it's very specific, and it's very factual. And so what SEG does is we take that information along with other information that we can gather or things that we've learned from our 25 years of doing threat modeling, and we develop these fully coupled physics-based models based on that information, benchmarking to the intel assessments, and then we can run Monte Carlo simulations about those physics-based models and figure out what is the true performance envelope of those different missiles. From a kinematics perspective, what is it going to look like to different types of sensors, and what other phenomenology may be involved that is going to change what a sensor would see or what a weapon system needs to deal with, like reentry phenomenology like breakup, ionized gases, waking, plasma generation, other things like that. And then also adding some intel uncertainty to our Monte Carlo analysis so that you're not designing brittle weapon systems because you're looking at a point design. This is the one thing we've seen that threat do. So, this high fidelity physics-based Monte Carlo threat modeling approach is very important for the Missile Defense Agency to not end up with brittle designs for the missile defense systems that are going to break if the threat does anything other than what they've done in a flight test. Next slide. So just to give you an idea of what we're talking about, when we talk about threat modeling, you might just think, okay, the missile goes up and it comes back down. What's the big deal? But there's a lot going on besides just the missile goes up and it comes back down. There's debris generation, like anytime you have a separation event, there's some kind of hardware usually that was holding the two parts together that gets thrown off, whether it's nuts and bolts or cables or welds or whatever. If it's a solid rocket, then that has debris associated with it. If you're going high enough and fast enough, then your spent objects may break up on reentry, and so any sensor that's watching the scene is going to have to deal with that. You have to model the RF signatures. If you're dealing with radars, you have to model the IR signatures. If you're dealing with IR optical sensors, it's not just ballistic missiles, it's cruise missiles, and then now we're starting to see things that are sort of in between cruise missiles and ballistic missiles with these new hypersonic threats. And then you have all this environment stuff to deal with. Ground clutter and sea clutter, precipitation, reentry phenomenology, like the waking and plasma sheathing, electronic warfare, which I can't really get into over an open line, but and then atmospheric propagation of radars and other things like that are also considerations that go into high fidelity modeling and simulation of missiles. Next slide. So we have a tool that we develop as we develop it at SEG, but it's considered government furnished information. So it's like a government owned tool that we develop for the government that is then available to other government contractors, primes, and program offices, called Pulse, which is a integrated threat scene generator. And it couples all of the different types of simulation that we produce for the government, the kinematics modeling ones, the debris, the clutter, which is a term that, again, I can't get into detail on, but it couples all of that physics together, and then everything that's in the scene gets rolled up into a single return for radar simulations or weapon system simulations that basically gives those simulations exactly what it would see if it was in a real world environment looking at a threat behaving as it behaves. And I don't have it written down here, but Pulse, the software, is at TRL level 7, and a lot of those underlying tools that feed the Pulse scene, the kinematics model, the debris model, those are TRL 9, and then the more advanced phenomenology models like the wake and reentry breakup are also TRL 7. Next slide. So this is just an illustration of what exactly is Pulse. It is a framework that ties together all these underlying simulations, which can be difficult for someone who's not used to using our data to tie everything together and get the full physics coupling out of it. So Pulse allows a user to just interact with Pulse, and then Pulse does all the convolving under the hood of the debris, the principal objects, breakup, waking, etc. Next slide. In terms of advanced threats, the sort of like what have you done for me lately sort of idea, because ballistic missiles are not that exciting anymore when you're looking at the world of what threats do we need to be worried about. So we've been developing hypersonic glide vehicle models recently. There's 3 MDA threats that we've developed, the actual real world hypersonic glide vehicle threats that we developed for the MDA. And then we've also developed a generic unclassified example HDV model that can be distributed freely to anyone who's interested in this group, start playing around with our hypersonic glide vehicle executable models in an unclassified setting to sort of get an idea of what our capabilities are, but also what you might need to be looking at if you're in this industry and trying to figure out how to deal with hypersonic threats, or if you're trying to design hypersonic vehicles for the US and want to be able to play around with the trade of different aerodynamic properties, different mass properties, etc. Next slide. In terms of the other advanced phenomenology, the reentry, waking, and plasma generation that I was talking about, there's a pair of tools called Phantasm and Wake. What Phantasm does it is a computational-based analysis tool that, based on a lot of observed data that we cobbled together from various observations and tests, et cetera. The tool takes all of that information in, and then you feed it in a particular realization.
Hey, Tom, you're cutting in and out pretty badly. I'm not sure what the issue is. Can you, I don't know.
My computer is giving me warnings that my VPN is acting up. Can you hear me any better now?
Not really. It's pretty crackly.
Okay. Okay. I don't know what to do about that.
So is there a way to maybe skip a couple of these just because we don't want to lose you? So to the extent that we can get as much as your presentation as possible, maybe click to some critical slides and we'll pray for the best. How about that?
All right. I'll do my best to talk louder and slower and the highlights, and hopefully you can get what I'm saying.
Just tell us which ones to skip to and we'll get there quickly. Thanks.
Okay. So Phantasm basically predicts the important information about hypersonic reentry bodies physics considerations. Next slide. And that feeds into WakeSim, which actually does the signatures calculation based on the parameters that Phantasm calculates, and it feeds that into the pulse simulation scene generator so that you get the added wake plasma reentry contributions to the scene signature added on top of the rest of the threat model. Next slide. So to summarize, SEG has been doing this work for the Missile Defense Agency and the Navy for a long time, and the expertise that we think we can bring to bear to benefit NSWC Crane and this technology bridge effort is in the areas of hypersonics, modeling and simulation. We have some expertise in AI and ML, and then if other people have other areas that they think we can help with based on what you've seen here, that would be great. We've already been participating in the NISTIC and AMTC areas along with IN3, Bill Kaiser and his team, and we're looking forward to working with everyone else in Indiana in the future. Chuck, did you have anything you wanted to add?
No, I think the only other takeaway is that there's been a lot, SEG has learned a lot about hypersonics flight from our modeling efforts aimed at, foreign threats that I think are probably of interest to people on the U.S. side that now are trying to stand up a hypersonics capability here in the U.S. So just what we've learned from looking at foreign intel data, what the capabilities of foreign threat weapon systems are, I think is a good discussion that we could have, obviously in a much different forum from this, but happy to have those kind of discussions too with the right people.
Great. Anything else from you guys before we kind of wrap up here? Well,
no, I don't
thank
think
all
so.
of you.
Thanks for the opportunity.
I'm really sorry for the technical difficulties. I guess, when you do something like this, you kind of have to anticipate that, but thanks for your patience. And for everybody on the phone, thank you so much for joining today. I'm most grateful for your active participation and your patience. We will follow up with all of you to make sure your questions are answered. We will also provide you with a list of the contact information, and we'll also be sending a survey out. We want your true feedback and appreciate your honest comments. But importantly, for those who've participated as presenters and others, please know that we're going to have a series of these kinds of events and others in the coming months. So we'll ensure that you're looped into those, and hopefully you'll have an opportunity to participate in those as well. But again, a sincere thank you for hanging in there. I know it's been a couple of hours, but look forward to seeing you in person at other events in the not too distant future. In the meantime, please stay safe and healthy. And again, thanks so much for joining. Everybody be safe. Thanks.
Thanks, Julie.
Thank you, guys.